Right. Yes, good evening my dear students and all the GATE aspirants who wrote this exam with the hard work and sincerity for the last 1 year. We as a team with most experienced faculty from ACE Engineering Academy and ACE Online, now we will have a live session on the discussion of this question paper for electrical engineering branch based on the memory from the students who wrote exam just few hours back. With the accuracy what we got, here and there the values of some components in the paper may not be accurate, but to the best possible accuracy we did it, and we will guide you the approximate answer. But still, once the official paper comes, we will go ahead with the accurate solution, again a session, and we will also give the paper solved for you to have the detailed marks discussion. I hope you really wrote well and all your hard work for the last 1 year or maybe 2 years will be true and you will have great success. And here I am introducing the great faculty team with so much of experience. Here in ACE Engineering Academy, we count experience in terms of number of batches. It is in terms of number of, most of the faculty here have more than 200 batches of experience, and we definitely have very accurate discussion of the paper. So let us go live as a team. We are all there to guide you now. Okay? ऑडियो चेक ओके ना चलो हाँ Yes, thank you for your patience, and my dear friends and student community. As we told, yes, we will be now coming live with all the detailed discussion and the accuracy what we got from the students. Now, before we start with each subject, as a faculty here, my name is B.S. Krishnavarma. I teach electrical circuits or network theory. But before going to each subject individually, let me give the conclusion about what happened in the paper for GATE 2023 Electrical Sciences. Now, we also kept the average here. Now, these are the last 3 years, how the marks division came, and specifically we will talk about GATE 2023 paper. Now, when it comes to electric circuits, okay, for EC we call networks, but electric circuits, this year you see, there are total 5 questions. 3 are 2 marks and 2 are 1 mark. Previously you see, this is 5 1 mark and 2 marks 1 and 4 1 mark 3. So you see overall, this time it is 8 marks, okay, this time it is 8 marks. That is electric circuits. And I will be discussing in detail, don't worry. Then when it comes to electromagnetic fields, we call EMFT, electromagnetic fields. This year you see 2 marks 2 and 1 mark 1, total 5 marks. Generally we neglect it, but no, see, GATE is always like a googly, right? You cannot neglect, all subjects are equal and important. So it is 5 marks, okay? Then when it comes to signals and systems, see, this is the biggest difference it makes. Reading such subjects which are highly mathematical. As electrical in our core engineering, BTech, we may neglect it. But see, signals and systems is the modern requirement because today world is digitalized. So see, 4 2 marks and 4 1 marks. See the weightage, 12 marks. It has become a deadly, dangerous and common subject. Then electrical machines, yes, 4 2 marks and 3 1 marks, which is our core subject. And power system, 4 marks and 3 1 marks, as usual 8 plus 3 11. Then control systems, 3 2 marks and 1 mark, 3 questions came. Then electrical and electronic measurements, 2 marks 1 question came, basically electrical it came. Then when it comes to digital electronics, 2 marks 1 question and 1 mark 2 questions. Analog electronics, 2 marks 3 questions, of course 1 mark none. Then when it comes to power electronics, one of the beautiful subject, 2 marks 2 questions and 1 mark 2 questions. And engineering mathematics standard, okay, 5 1 marks and 3 questions of 2 marks. And of course general aptitude, 2 marks 5 and 1 mark 5, 15 marks. This is based on the accuracy what we got, sir. Multiple students, and we did discuss with hundreds and hundreds of students who came out of the exam hall, and we cross-checked with them, and this is most of the accurate. Though we started at 6 p.m, but I say from our institute we will give you the most accurate solution. Then yes, now this time in GATE 2023 electrical paper, yes, you see now numerical type, okay, numerical type if I go, there are total 28 questions, 49 marks. MCQ, okay, multiple choice, there are 31 questions of 42 marks, and MSQ this time you see now 6 came, total 9 marks. So this is the accurate weightage based on the knowledge what we got from the students, okay. Now we also gave what happened in GATE 2021, 2022 and now 2023. You can see based on that average which subject dominates where and how. And of course the 3 core subjects, you know, power systems, okay, machines and power electronics, okay. You know, these are the core subjects, okay, machines, power system and power electronics. But you see most of the weightage are in the fundamental common subjects. So as a student you need to balance everything. There is nothing like important. If any student asks me, sir, which is the important subject? No, in competitive exam there is a wrong question and there is no important chapter. All are equal and important, and in GATE they distribute marks, sometimes X subject more, Y subject more, but they have a common thing, that is aptitude level of solving, that too in 1 minute or 2 minutes, okay. So we will at the end also discuss what is the standard. Each subject teacher will come in front of you and talk the standard about the paper, okay. And once the official paper come, we will give the accurate solution. Now I would like to welcome, okay, our team from Signals and System, okay, Professor Narsimham and Professor Srikanth to take over. So we will go subject by subject, sir, okay. Yes, we will go with the first subject, Signals and Systems.
Thank you, Verma sir. Student friends, today you are aware from signals 4 1 mark and 4 2 marks questions are given. The weightage is slightly increased compared to the earlier years. Let us see the models. This is a simple sampling model, regular model. A signal 2 cos 180 pi t into cos 60 pi t is sampled at 200 Hz. Then later on it is passed through an ideal low pass with cutoff 100 Hz. He has not asked what frequencies are present at the output of the filter. What is the maximum frequency that appears? This can be written as 2 cos A cos B style, cos 240 pi t one term. What is another term? 120 pi t. In Hertz scale, our frequencies are what? 120 Hertz as well as 60 Hertz. Input side, two frequencies are present. Then they are passed through a device. What is the device? Sampler. What is the sampling rate mentioned? 200 Hz. So later on they are passed through ideal low pass. What is the cutoff number mentioned, sir? 100 Hz. So what is the maximum frequency that is present at the output of the filter? How we are finding frequencies at the output of sampler? At output of sampler, how we are finding the frequencies? Recollect, spectrum of sampled signal is 1 by Ts sigma x of f minus nfs. So now our job is finding out the frequencies at the output of sampler. Input side, how many frequencies are given? Two frequencies, 120 and 60, fs is 200. Simple addition we have to perform. Find out the frequencies at the output of sampler. That will form two combinations like this. Frequencies at the output of sampler is two combinations. What are they? FM1 plus or minus n into fs. FM2 plus or minus n can be varied from 0 to infinity. As they are sinusoidal function, we can say plus or minus FM1. What are that numbers? 120, 60, 200. Substitute there. 120 plus or minus n into 200, one combination. FM2 plus or minus n into fs means what is the combination? 60 plus or minus n into 200. Simply I substituted FM1, FM2, 120, 60, fs number 200. N value 0, 120, no chance. Because our cutoff is how much? Cutoff is how much? 100 Hz. For the low pass filter, cutoff is 100 Hz. If I take n value 1, sir, that will make which number? 120 plus or minus 200. Chance for 80 Hz. Of course, 320 also there. I am looking for the frequency which are less than that one. Here if I substitute n place 0, chance for 60 Hz. N plus 1 plus or minus 60 plus or minus 200. That will make 260 one number, 140 another number. As our cutoff is 100 Hz, chance for which numbers? 80 Hz and 60 Hz. But what is asked in the question? What is asked in the question? Maximum frequency appearing at the output of the filter. What is the maximum frequency number? We got 80 Hz. That we solved in the. So for that question, 80 Hz is the correct answer. Okay, very simple model, habituated model in the classroom discussion. We know it. FM1 plus or minus NFS, FM2 plus or minus N into Fs. Let us see the next model that is asked. Oh, funny question. Jet transform is given with ROCR. Which of the following statements are true? X of n is a right-sided sequence, then only DTFT of xn converges. What is the meaning of DTFT of xn converges? Stability. Fourier transform is defined means, indirect meaning in jet transform is what? Stability. Stability means what is the compulsory requirement? ROC must include what? ROC must include what? Unit circle in the jet plane. So there are 3 poles, 1 by 5, 2 by 3, 3. 3 poles are there. What that fellow is saying in the first option, DTFT of xn converges if ROC is such that xn is right side sequence. For a right side sequence, take the largest pole in magnitude, gone. Because what is our expectation? Stability is our expectation, no chance. DTFT of xn converges if ROC is between 2 by 3 to 3, correct. Why it is correct? We have a pole at 2 by 3, 0.66, another pole at 3, another pole at 3. Unit circle is reference. When you take between 2 by 3 to 3, our shaded portion very neatly including unit circle. DTFT is defined indirect meaning is what? Obeying stability. When stability is guaranteed, our ROC must include unit circle. That is possible only for which option? Option B is correct answer. The thought you need for this particular question is what? DTFT of the given signal converges means what? Stability. What is stability in jet plane? ROC must include unit circle. Let us see the next model. Classroom discussion, so many fellows are aware of this graph. What is that? It is a simple ideal low pass filter which covers from minus omega naught to omega naught. That is the spectrum given. What is the inverse Fourier transform of this one, sir? Standard sin 80 by pi t style. Sin 80 by pi t, of course, that is given as omega naught. When you draw that curve, roughly the graph is like this. Roughly. At 0, it maintains the maximum amplitude of omega naught by pi according to our L-Hospital rule. Actually, we are getting 0 by 0 condition. When you apply L-Hospital rule, that will be converted to omega naught by pi. What is the first option stated? Small x0 decreases as omega naught increases. That is wrong. Signal amplitude decreases if omega naught increases. If omega naught is more, signal amplitude dominates or not. So first option is clearly wrong. Xt tends to an impulse as omega naught tends to infinity. First, let us look after the last 2 options, C and D. He is saying at a particular frequency, the amplitude may be 1 by pi or minus 1 by pi. What is our general solution? Sin x equals to 0 means, what is our general solution? Plus or minus n pi means t equals to plus or minus n pi by omega naught. But what that fellow is saying, at pi by 2 omega naught, it may become the amplitude like that. So what happens if I substitute there? That particular instant. What is that instant given? Pi by 2 omega naught. If I substitute there, pi by 2 omega naught directly in the place of t, he is saying the answer is 1 by pi. That is clearly wrong. Sin pi by 2 is 1, but we got 2 omega naught by pi square. Of course, this is also wrong, which is 100% correct. Xt tends to an impulse as omega naught tends to infinity. We studied, according to shifting property, we have chance of approximating any signal as impulse. In regular classroom discussion, we studied that. As omega naught tends to infinity, it can approach to impulse shape. Omega naught is infinity means what is continuous impulse graph? It has infinite amplitude at origin. Correct or not? So option B is correct. This is also simple habituated model. Habituated model in the classroom discussion. Let us see the next model. Oh, another funny model, convolution, slightly good model, we can say. 2 signal graphs are given. That fellow is expecting if the convolved signal amplitude is maximum at a particular instant, that will happen for which instant? Here there are different ways of answering this question. Because he has asked only for instant of time, let us see. Generally what we'll do, step function convolved by step function is ramp signal, expressing the given signal in terms of step and ramp. Step function convolved by ramp is parabolic signal, writing both signals in terms of that way. But he wants maximum amplitude is occurring at a particular instant. What is that instant? What is normal convolution formula style, sir? Recollect everyone. Integral x of t minus tau, y tau d tau, where we are using folding, shifting, multiplication and integration or not. If I take folded version of x of minus tau, Of course, minus 1 to 1 covers x of t minus tau. By adding the limits, it becomes t minus 1 to, when you enter this limit t minus 1 between 3 to 5, where it is maintaining positive amplitude, the other signal it is maintaining positive amplitude. When you enter t minus 1 between 3 to 5, chance of getting maximum amplitude. T minus 1 is 3, so the instant that is happening is at t equals to 4, the maximum amplitude is obtained for z of t. Because according to our thumb rule, what are the limits? Sum of lower limits minus 3 plus that 1.5, sorry, minus 1 plus this number 1 plus 5. At 6 it will come down. At 6 it will come down. So the maximum amplitude can occur only at t equals to 4. So the other models are covered by my faculty friend Mr. Srikanth. Okay, just wait for 1 minute. My faculty friend will come. 1 minute.
The next question from signals and systems is, this is a question from Laplace transform, asking the question to find impulse response. Given differential equation dy of t by dt plus 3 into y of t equals to 2 into x of t, what is the impulse response? It's very simple one, fundamental one. Apply Laplace transform to the given differential equation. dy of t by dt Laplace transform is s into y of s plus 3 into y of s is equals to 2 into x of s. Take y of s common, then s plus 3 equals to 2 into x of s. What is the transfer function? H of s is equals to y of s divided by x of s, that is equals to 2 divided by s plus 3. In the question asking to find impulse response, so apply inverse Laplace transform to the transfer function. Then it results impulse response h of t. What is the inverse of 1 by s plus 3? E power minus 3t u of t. So 2 e to the power of minus 3t u of t. This is the correct option. So 2 e power minus 3t u of t. This is the right option. Next, it's a question from signals chapter asking to find the fundamental time period. The signal given as 1 plus 3 sin 15 n pi by 8 plus 3 pi by 4 minus 5 sin pi n by 3 minus pi by 4. So whenever you are finding the fundamental time period, even though if DC added, fundamental time period doesn't change. So no need to consider this now. Now consider this one and this one. See, what is omega 1 given? 15 pi divided by 8. What is n1? 2 pi divided by omega 1 into m. So 2 pi divided by 15 pi divided by 8 into m. Pi gets cancelled, 16 by 15 into m. So choose the smallest value of the integer such that n1 is integer. So what is the smallest value of m? 15. 15, 15 cancel. Then n1 you will get 16. What is omega 2 given? See here, pi by 3 given. Pi by 3. So n2 is equals to 2 pi by 3 into m. So pi cancel. So 6m. So n2 is equals to, you will get 6. So find out n1 by n2. n1 by n2 is how much? 16 divided by 6, that is equals to 8 by 3. So what is the fundamental time period? It is either 3n1 or 8n2. So n1 is how much here? 16 into 3, 48. So the answer is 48 is the answer. Next question. This is the question from DFS and DTFT. Both combination is given. Good question. See here. The discrete time Fourier transform of a signal x of n is x of omega equals to 1 plus cos omega into e power minus j omega. Consider that xp of n is a periodic signal of period phi given, such that xp of n is x of n for n equals to 0, 1, 2 and 0 for n equals to 3, 4. And he has given that DFS expansion this is, and AK is the DFS coefficient. And in the question asking that magnitude of the coefficient A3, yes. So first of all, we need to find x of n. So what is x of omega given? 1 plus cos omega into e power minus j omega. So first to find I dt of t. X of omega is equals to 1 plus cos omega into e to the power of minus j omega. See here, 1 plus cos omega into e power minus j omega. So x of omega equals to 1 plus, how to write cos omega? E power in terms of complex exponential, e power minus j omega divided by 2, whole multiplied with e to the power of minus j omega. Then x of omega is equals to multiply e power minus j omega plus 1 by 2 plus 1 by 2 e to the power of minus j2 omega. Apply I dt of t. If I apply I dt of t, what is the sequence you will get? This is del of n minus 1 plus 1 by 2 del of n plus 1 by 2 del of n minus 2. So if I write it in the sequence form, x of n is equals to 1 by 2 comma 1 comma 1 by 2. This is x of n we got. So starting index is 0, 0, 1, 2. And what is xp of n? Tell me. He has given that xp of n is equals to, once you see here, x of n for n equals to 0, 1, 2 and equals to 0 for n equals to 3, 4. Yes. So xp of n is equals to here 1 by 2 comma 1 comma 1 by 2. Okay. This we got for, this is for n equals to 0, n equals to 1, n equals to 2. And what about n equals to 3, 4, 0, n equals to 3, 4. So we got one period of the signal. What is one period of the signal here? 1 by 2, 1, 1 by 2, 0, 0. Yes. So find the DFS coefficient. What is the DFS coefficient formula? AK is equals to 1 by n, summation n is equals to 0 to capital N minus 1, xp of n e to the power of minus j 2 pi by n into nk. What is the capital N value period given in the problem? 5. Substitute that. AK is equals to 1 by 5, summation n is equals to 0 to 4, xp of n e to the power of minus j 2 pi by 5 into nk. He is asking to find A3. So substitute k equals to 3 here. Then A3 is equals to 1 by 5, summation n equals to 0 to 4, xp of n e to the power of minus j 2 pi by 5 into n into 3. But what is xp of n? At n equals to 0, how much? See here. At n equals to 0, 1 by 2. N equals to 1, 1. N equals to 1 by 2. Substitute those values. A3 is equals to 1 by 5 into, see here, for n equals to 0, how much? 1 by 2. 1 by 2 e power 0 is 1 plus. For n equals to 1, how much? 1. So 1 into e to the power of minus j 2 pi by 5 into 3 plus for n equals to 2 1 by 2 e power minus j 2 pi by 5 into 2 into 3 6 for remaining values 0. He is asking what is the magnitude. Here you have to apply some simple logic here for simplification. See here, A3 is equals to 1 by 5 into 1 by 2 plus, you write this term here. Last term I am writing here. 1 by 2 e power minus j 12 pi by 5, and second term I am writing at the end. E to the power of minus j 6 pi by 5. See here, I am writing these two terms at a place. This term I am writing at the end. So A3 is equals to 1 by 5. From these two terms, you take e power minus j 6 pi by 5 common. Then e power j 6 pi by 5 plus e power minus j 6 pi by 5. I am taking from these two 1 by 2 e power minus j 6 pi by 5 common. And the third term as it is, e power minus j 6 pi by 5 as it is. If you apply this logic, then problem is going to be simplified. 1 by 5 into e power j theta plus e power minus j theta, 2 cos theta, 2 gets cancelled. E power minus j 6 pi by 5, if I take common here, cos 6 pi by 5 plus 1. Yes, he is asking magnitude. Mod A3 equals to mod of e power minus 6 pi by 5, how much? 1. So 1 by 5 into mod of 1 plus cos of 6 pi by 5. This is the value we need to find. So what is the value of cos 6 pi by 5? Minus 0.809. 1 by 5 into mod of 1 minus 0.809. Let's simplify this value, and the final answer is 0.0381. This is the value asking in the question. And the last one, this is MSQ question from LTA system chapter. Which of the following statement is or are true? The impulse response given that 0 less than mod h of n less than 1 for all n, then the system is said to be stable. What is the condition for stability? Summation n equals to minus infinity to plus infinity. Mod h of n should be less than infinity. But once you observe here, he has given that mod h of n value lies between 0 to 1. Suppose let us assume I am taking h of n, mod h of n equals to 1 by 2. Then what is the value it is going to be? Minus infinity to plus infinity 1 by 2. How much you will get? Infinity. So the system becomes unstable. Yes or not? System becomes unstable. So this is wrong one. And see the second one. A discrete time LTA system has impulse response h of n of finite duration, then the system is stable. Finite duration means FIR filter, yes. So if the impulse response is of finite duration, this value never tending to infinity, yes, so system is going to be stable, correct. If an LTA system is causal, then the system is stable. No, because let us take this example, e to the power of 2t into u of t minus 2. What is the nature of the system? Causal, but it becomes unstable system. Yes or not? Yes. So causal system need not be stable, it may become unstable also. So this is also wrong option. Yes, a discrete time LTA system is causal only if its response to a unit step input u of n is 0 for n less than 0. Yes, it is correct. See here, what is the relationship between step response and impulse response? See here, what is the input is giving? U of n input is giving. If the input is u of n, what is the output of the LTA system? Step response. What is the relationship between step response and impulse response? Summation k is equals to minus infinity to n h of k. This is the relation. He has given that when the input is u of n, the value should be 0. The response of the system is 0. Means this value should be 0 for n less than 0. Okay? If n is less than 0, then s of n becomes, then the limits are going to be 0 to n h of k. Okay? Yes. So, means positive values of k only, this is going to be exist, means h of n should be 0 for n less than 0. Yes, that is the condition for causality. So this statement is also correct. So A is correct, D is correct. So these are the 8 questions from signals and system subject. Now our professor, measurements subject faculty Ramesh sir will continue the session.
Right. Now I am going to take the question discussion from the measurement subject. The question here is star connected balanced load. 3-phase star connected balanced load is given and it is supplied from a 3-phase 400 volt RMS. So therefore, what is the value of VL they have given? VL is equal to 400 volt and the so and so voltage source with the wattmeter reading is 400. So therefore, simply the wattmeter reading is 400 value and the line current is IL is equal to how much value? 2 ampere. Now, then the power factor of the load per phase, power factor of the load per phase. Sir, if you observe this entire diagram, the answer is straight away, current coil is connected in one phase, potential coil is connected between other 2 phases. So what does it mean? Current coil is in one phase, potential coil is connected between other 2 phases. Straight away question, it reads a reactive power. So therefore, what we can do here, whatever the wattmeter reading is there, it reads reactive power. What is the reactive power formula? According to the wattmeter connection, VL IL into sin phi. So therefore, what is the wattmeter reading? 400. So let us substitute here 400 and what is VL? 400 volt and what is IL? IL is 2 amperes into that is sin phi. So therefore, from this what we can write 400 cancels, so simply sin phi is equal to 1 by 2. Sin phi is equal to 1 by 2. So therefore, the phi value is, therefore phi is equal to 30 degrees. But what he is asking, the power factor of the load. So straight away, therefore, power factor cos phi is equal to, what is the value? Cos 30. So cos 30 is 0.866. But if you see the options, he has given that 0.707 lagging, 0.5 leading, 0.866 leading and UPF. So therefore, in this question, lagging or leading not mentioned. So therefore, only one option is there with this 0.866. So straight away, option C is the answer. So this is the question from the measurement subject. Now, next, the questions will be discussed by our faculty, Pawan sir, digital subject.
Now let us see questions from digital circuits. There was a question from analog to digital converters. An 8-bit ADC converts analog input in the range 0 to 8 volts, corresponding digital code as per conversion characteristics shown below. So what is the analog sample voltage given is 1. The V in analog sample is given 1.9922 volts. For the given information, from the given information, the analog range is 0 to 5 volts. From this, if we calculate step size, delta is V max minus V min divided by 2 power n, with that 5 volts minus 0 volts divided by 2 power 8, it is 19.53 millivolts. The step size is 19.53 millivolts. Now, analog sample voltage is given 1.9922 volts. If I consider step size into 102 steps, it is equals to 1.9921 volts. If I consider delta into step size into 103 is equals to 2.0117 volts. It is in between 102 steps above and below 103 steps. So we need to consider from the given characteristics up to 19.53 volts, it is 00. Hexa means 0.00000000. That means it is above 19.53 millivolts. Then it is 01 hexa means 00000001 binary. So now if it is 102 steps above and less than 103 steps means according to the given characteristics, we need to consider it is 102 steps. 102 decimal equivalent is equals to 0110. 0110 in binary, it is equals to 66 hexa. From the given options, we can choose option C. Option C. Let us see next question on sequential counters. Let me consider it is D1, Q1, D0, Q0. So from the given circuit and from the given information, if you are observing, neglecting the delays, the decimal equivalent of binary sequence ABCD of initial logic which will not change with clock is. That means the state should not be changing, then ABCD decimal equivalent also will not be changing. For which state it is not changing and what will be the decimal equivalent of ABCD if you observe. If I consider present state Q1, Q0, and let me consider A, B, C, D inputs as well as flip-flop inputs. Let me say it is D1, D0 and also next state Q1, Q0. So from the circuit if you are observing, what is that A? It is a Q1 bar. A is Q1 bar. What about B? It is Q1 bar, again complement. Out of NOR gate, what we are getting is it is Q1 bar again complement which is Q1, and if you are observing C which is Q0 from our circuit. And what about D? It is Q1 XOR Q0. Q1 XOR Q0. Let me start with 0, 0. Then let us see what will be the next state for this. So if you are observing Q1, Q0 is 0, 0. Q1 bar will be 1. Q1 will be 0, Q0 is 0 and Q1 XOR Q0 also 0. Then what about D1 connected to? D1 connected to which is Q0 and D0 connected to again Q1 XOR Q0. Q1 XOR Q0. So from this present state 0, 0, here we are getting present inputs is 0 again Q0 and Q1 XOR Q0 also 0. Next state is again 0, 0. If you are observing 0, 0 is initial state, then next state also 0, 0. It continues in 0, 0 even though you are applying clock cycles for years. So it is starting with 0, 0 which we discuss as lockout condition, our counter circuits. So when it is 0, 0 initial state, it is into 0, 0 only. Even though you are applying clock cycles, again it is back to 0, 0, or it will remain in 0, 0 only. Then what is that ABCD we are getting? For this Q1, Q0 is 0, 0. ABCD we are getting is 1, 0, 0. Decimal equivalent of this 1, 0, 0 is 8. The question it is asked is what is the decimal equivalent of ABCD? So answer is 1, 0, 0 decimal equivalent is 8. So answer is 8 for this question. So these are the digital questions we have seen from memory based question paper. So next power electronics will be continued by our faculty.
Hello everyone. Now we are going to discuss the questions from subject power electronics. Altogether there were 4 questions from the subject. Let us start. The circuit shown in the figure has reached a steady state with thyristor T in an off condition. Assume that the latching and holding currents of the thyristor are 0. The thyristor is turned on at t equal to 0 second. The duration in microsecond for which the thyristor would conduct before it turns off is. Okay, and here they have given this circuitry. So my dear friends, if we check here, it is strictly mentioned that initially my thyristor is in an off state and latching current and holding current of the thyristor is equal to how much? It is a 0 ampere. Alright, and when thyristor is in an off state, then my circuit is at a steady state. Okay, so tell me here, when thyristor is in an off state, when thyristor is in an off state means it is like an open circuit here. Yes or no? So when thyristor is acting as an open circuit, that is for before t equal to 0, because at t equal to 0 we are turning on the thyristor, na? Right? So before t equal to 0, for t less than 0, yes, this is in an off state. When this is in an off state, how the current will flow? Current will flow like Vs, capacitor, inductor, resistor, and again back to the supply voltage. What will happen? My capacitor will go on charging, right? To which voltage the capacitor will be getting charged? Capacitor will be getting charged like a polarity plus here, minus here, and how much voltage? It is equal to 100 volt. Capacitor will be charged to the voltage of 100 volt before t equal to 0. Alright? At t equal to 0, we are turning on thyristor. Now tell me, at t equal to 0, when this thyristor is turned on, then yes, one current will flow in this loop. Alright? And second current is my capacitor will go on discharging in this loop. Right? Now tell me whether this circuit, it is like initially charged a capacitor and across it we are having the inductor connected. Is it like a tank circuit? Yes, it is like a tank circuit. So let me draw the circuit for t greater than 0. For t greater than 0, the circuit is like this. Supply voltage 100 volt. Here it is a thyristor. resistor, initially charged capacitor, inductor, yes, L, C, capacitor is initially charged to the voltage of, let me write it as Vs, which is equal to 100 volt. This is also equal to 100 volt. Here it is thyristor and here it is a resistor R. Alright. Here through the thyristor we are having the two currents flowing. One current is flowing in this loop, right? And second is capacitor is discharging here and again it will charge to the reverse polarity. Let me consider current in this branch is a IC. Current here is a IT. Alright. Now tell me what is the IT value? Yes, it is very straightforward. If you recall the current commutation chopper circuit, the same thing is happening in the current commutation chopper. Alright. So what is the IT here? It is like a 100 volt and here it is only resistor R we are having. So can I write IT equal to 100 upon resistor R value. What is the resistor R value? It is a 4. So it is equal to 25 ampere. IT is equal to 25 ampere. Now what will happen here? This is a tank circuit. My capacitor will discharge and again it will charge to the reverse polarity. What is the expression for IC here? Yes, IC is equal to, we know it is a Vs under root C by L into sine of omega 0 t, right? So it is a Vs into under root C by L into sine of omega 0 t. These type of questions were already discussed during the classroom sessions, right? Yes, so here put the values. Vs is 100 volt into under root C by L. C is equal to, yes, 1 microfarad. 1 into 10 to the power minus 6 upon L is equal to 4 microhenry into sine of omega 0 t, right? Omega 0 t. So therefore my IC is equal to, it is equal to 100 into 0.5 into sine of omega 0 t. So it is equal to 50 into sine of omega 0 t. Alright, this is my IC. Now what is happening in the circuit after t equal to 0? My capacitor is discharging and again it will charge to the reverse polarity. So my IC waveform is like this. Yes. And VC waveform is like this. This initial voltage Vs, right? And this is minus Vs. Okay, IC is a sinusoidal, VC is a cosinusoidal. Alright, what is this time? Here time is pi by omega 0. Alright, now here what is happening in the circuit? My capacitor is discharging here and again charges to reverse polarity. It discharges and charges to reverse polarity. So reverse polarity means again it is like a plus here and minus here. Once capacitor discharges and charges to reverse polarity, then again it will start discharging now, right? So when capacitor discharges means current will flow in the clockwise direction. So through thyristor the current will be flowing like one current is, this is 25 ampere. Second current is discharging current of the capacitor. And when IC becomes equal to, IT, your IT will become 0, right? And therefore my thyristor will turn off. So here if you check here, yes, when IC value becomes equal to, IT value becomes equal to IT means 25 ampere, then my thyristor will turn off. So let me consider this time is a T1. This time is T1, right? So my thyristor will be in a conduction mode from this point till this instant only. So what is the conduction time of thyristor? Yes, it is pi by omega 0 plus T1. Okay. So conduction time of thyristor T on is equal to pi by omega 0 plus T1. All right. Now how to find T1? We know at T equal to T1, at T equal to T1, IC equal to I0. IC is equal to IT, which is equal to 25 ampere, right? IC is equal to IT, which is equal to 25 ampere. Now here we are having the expression for IC. In that we need to replace this T with T1 and replace IC with equal to 25, and from this we can find T1 value, okay? And what is omega 0? Omega 0 is equal to 1 by root LC, and accordingly we can simplify, and after simplification we will get T1 equal to 7.33 microsecond. 7.33 microsecond. All right. Next, the circuit shown in the figure, the switching frequency S1, S2 is F is equal to 100 kilohertz. Then the average output voltage is, okay, they are asking V0 average. So if you check this circuit, supply voltage is 20 volt. Here during 0 to 3 microsecond, the S1 is in a on state, and S2 is in a on state from 5 to 8 microsecond. So if we draw the waveform for V0 here, yes, it is like this. Yes, when 0 to 3 microsecond, when S1 is in a on state, current will flow like 20, that is Vs, S1 load and again back to the Vs. What is output voltage? Output voltage is equal to 20 volt, right? So here I am getting output voltage is equal to 20 volt. After that, here the load current they have given constant, means load is highly inductive. So therefore when S1 turns off, this inductor will go on releasing energy through this diode. All right. So my diode will be in a conduction mode. Let me consider this is D1 and this is a D2. So here when D2 is in a on state, output voltage is 0. After that, even though we are applying the controlling signal to the switch S2, but this inductor will not allow the S2 to turn on. So my diode D2 will be in the conduction mode only. So here if we check, output voltage waveform will be like this, and conduction is yes, here it is S1, and for remaining all period it is D2, D2 and D2. This voltage is a 20 volt. So this is simple waveform. We can find V0 average. V0 average is equal to 20 into 3 into 10 to the power minus 6 upon 10 into 10 to the power minus 6, which is equal to 6 volt, right? Output voltage is equal to 6 volt. Next, a semiconductor switch need to block the voltage V of only one polarity, that is they are asking unipolar positive voltage blocking, and during the off state as shown in figure 1, and carry the current in both directions, that is bidirectional, unipolar and bidirectional switch they are asking. All right. So here, yes, these are the options. In the option there is a slight correction. Here it is a diode present, right? Yes. So if you check here, they are asking unipolar and bidirectional. Tell me, yes, when supply voltage is positive and when this thyristor is in an off state, then what will happen? This switch will block the forward voltage. And when this BZ is in an on state, what will happen? Current will flow in this direction. Okay. And when Vs is negative, the reverse current will flow through the diode. So this is unipolar bidirectional. And what about this one? This is a unipolar and unidirectional. Okay. So this is not a true. Next, this one is unipolar unidirectional. So this is also not true. But if you check this one, this is unipolar bidirectional. So this is the MSQ type question. Correct answer is option A and D. Option A and D are the correct option. All right. Next, the circuit shown in the figure, T1 and T3 are triggered at 60 degree. T2 triggered at 240 degree. Then the average output voltage V0 is. So here they have given alpha is a 60 degree. Right? Because after 180 degree, this thyristor T2 will become forward bias, and 180 plus alpha, that is plus 60. 180 plus 60 means 240 degree. Okay. So that's why here they have given 240 degree. So this is simple circuit. It consists of 3 thyristors and 1 diode. We have already discussed this type of circuit, okay? And what is the output voltage? My V0 average, V0 waveform will be like this. 0 to alpha, alpha to pi, pi to pi plus alpha, and then 2 pi, all right? So therefore, yes. We are getting this type of output, alpha, pi, pi plus alpha, and 2 pi, all right? So if we simplify, we will be getting V0 average is equal to Vm by 2 pi into 1 plus 3 cos alpha. Put the values and we will be getting the answer as a 39.79 volt, okay? 39.79 volt, all right? So friends, these are the questions from subject power electronics.
Yes, my dear students, how you wrote? Feeling full tensed? I am there to relieve your pressure. Myself, B.S. Krishna Verma, faculty in electrical circuits. For EC we call network theory, but electrical circuit part for electrical I am discussing. And luckily, because of so much time I got the most accurate questions with the most accurate values and detailed solutions I am discussing with you. And my subject, it is moderate to little difficult, let us accept. 2 bits are very easy, but 3 bits are outstanding. So moderate to difficult, I accept my subject. There are total 5 questions, 3 2 marks, 2 1 marks, total 8 marks. And I would say it is moderate to difficult is the standard for my subject, and 3 lengthy questions came and numerical type all. Differently solving is important. Let us do that, okay? Now this is the first question. What is VAB? He is asking VAB. But let us simplify. This is a simple node, okay? This is a single node, okay? This is a node. So I will simplify. And moreover, in a parallel system, voltage is same. 3 parallel 1.5. So directly I can write. So left side is independent. So if I show this is 8 volts, that V1 is 8 volts, I am writing here. Now, this is half ohms. Okay, I will write like this. This is half ohms. Now these two are parallel now. I can lump them. Though he is asking VAB, in a parallel system voltage is still same. So 3 parallel become 1.5 and I need this VAB. Okay, 3 parallel is how much? 1.5 ohms. And this is of course A and this is of course B. And this junction is B, everywhere B. Now this side no need to worry. Why should we waste your time? Voltage is there. Whatever is there, let it go. Voltage is already there. We can do voltage division. Even if you want to simplify, here the current source will come and here these 2 parallel 1 ohm will come. But I am least bothered now. Why should we waste your time? Chalo, VAB, this voltage I want. So this 8 volts will be divided between these 2 series resistor, voltage division rule. This voltage VAB is, total voltage is 8 into same by sum. Same is how much? 1.5. By sum is how much? Sum is 1.5 plus half, 2. So yes, it is 4 into 1.5. It is 6 volts. Yes, it is 6 volts. It is 6 volts. Okay. So the first answer is very easy. It is of course 6 volts. Now let us go to this. Now this is a very, very good problem, sir. It is an initial condition problem. Here the switch is getting opened at t equal to 0. It is a 10 amps, 3 ohms, 2 ohms, 2 ohms, 1 millihenry, 10 micro. Now different students gave me these different values. Actually students may not remember. Some gave 100 micro, 10 milli, but doesn't matter. Here luckily because he is asking initial voltage across capacitor VL of 0 plus, voltage across inductor at t equal to 0 plus, that is VL of 0 plus. Luckily these values will not affect the answer. So some students gave me the different values, but it won't affect. Now how to find initial conditions? To go to initial condition I should write 0 plus circuit. But to write 0 plus circuit I need the initial values, memory elements. So first I will go to 0 minus circuit. Chalo, if I go to 0 minus circuit, everybody, okay, 0 minus, t equal to 0 minus. 0 minus means previous steady state. Previous steady state, this switch was closed. Okay, this 3 ohms is here. This current is also here. Okay, 3 ohms is here, current here. But now, yes, in the previous DC steady state for 10 amperes, in the previous DC steady state for 10 amperes, you know, inductor short, capacitor open. So in that regard, if I go, here inductor is short, capacitor is open, Okay, inductor is short, capacitor is open. Yes or no? Yes. So in the previous DC steady state, yes, 3 ohms, 10 amperes, switch was closed. Inductor is short, capacitor is open for DC steady state. So this is however 2 ohms, 2 ohms. Now let us find the memory values of memory elements. What is the meaning of memory values of memory elements? There are 2 memory elements. One is inductor, one is capacitor. The memory values of memory elements are inductor current and capacitor voltage. So I will first find IL of 0 minus and I also need VC of 0 minus. This is the previous steady state. Chalo, here somehow current won't flow. Now if you do current division rule, this 10 will come. This is open, so these 2 and 3 are in parallel. So current division rule. This current will be total current 10 into opposite. What is opposite? 3. By sum is 3 plus 2, 5. This is 6 amperes. No doubt this is 6 amperes. So one memory value we got. But when 6 amperes is going through 2, this is 12 volts. Yes or no? Passive notation. When 6 amperes is going through to 12 volts, the 12 volts only will come here. So what is VC of 0 plus 12 volts? Chalo, I got the memory values of memory elements. Now with this initial conditions, now let us write the 0 plus circuit. Chalo, now I am writing to equal to 0 plus. What is the sudden change that happened, everybody? The sudden change that happened here is switch got opened. So this 3 ohms is waste. Okay. So 10 amps only will be there. Okay. The 10 amps only will be there. But interestingly here, What is the 0 plus circuit? You know at 0 plus, inductor open with initial condition, yes or no? And capacitor short with initial voltage. Inductor open with initial condition and capacitor short with initial voltage. Okay? So this is however 2 ohms and this is also 2 ohms he gave, I think, yes or no? Yes. Okay, this is 2 ohm, 2 ohm. But what are the inductor current? Inductor current 6 amperes. This is 6 amperes. Okay, this is 6 amperes. And what is the capacitor voltage? 12 volts. 12 volts. This is plus and minus 12 volts. But what I want everybody, this is the original question, VL of 0 plus. This is what I want finally. VL of 0 plus. Now this is already 3 amperes. Sorry, 10 amperes. I think this is 10 amperes, right? Yes, this is 10 amperes. Okay, this is 10 amperes. Is it okay? Yes, you see now everybody? Yes, this is 10 amperes. Now see, now I need this. Now from KCL, out of 10, 6 went. Out of 10, 6 went, so this is 4. When 4 is going through 2, yes, it is 8 volt. Okay, and 6 is going through 2, it is 12 volt. So now let me write a KVL. I am writing a KVL clockwise. See, starting from here, minus 12, minus 8, minus 12, minus 8, plus 12 plus VL. Plus 12 plus VL of 0 plus is 0. So VL of 0 plus is 8 volts. 8 volts. Okay, so very simple, sir. See, these are the very simple good problems. First go to 0 minus previous DC steady state. Previous DC steady state switch was closed. Now inductor steady state short, capacitor open. So do current division and find the initial condition. One is inductor current, capacitor voltage. And once you got these memory values of memory elements, then write the 0 plus, then write the 0 plus. If I go to 0 plus, yes, here the switch has opened. Okay, then inductor open with initial condition, capacitor short with initial condition. That is what is a 0 plus, sir. Very interesting circuits. So once you got this, now from the same data, I got this VL by writing the KVL. Rest of the things you can observe. Okay, so answer is 8 volts. Okay, that is a beautiful question. Now, sir, this was the data we were actually waiting because some students gave both capacitors for me here. Some students did not give me dependent source, but I got everything now. Okay, so this is a problem where he is asking to find the Thevenin's voltage or open circuit voltage at an instant. Generally, we define Thevenin's voltage or open circuit voltage at a steady state. First, we will find that steady state because it is in terms of AC circuit analysis, AC signal. But he's asking to find the Thevenin's voltage at an instantaneous Thevenin's voltage. So we'll substitute that time. Okay, chalo, let us do that now. Now, first of all, what I will do, see, he gave the reactances and this is a current dependent voltage source. First, let us do the source transformation, sir. This source transformation, current source in parallel can be converted into voltage source in series. That will save a lot of time. Chalo, the same circuit, here it is RC first. And here is the dependent source, which I am not changing either. But here, this current source in parallel can be converted into voltage source in series. So this is 10 ohm minus J10 ohm. This is 10 ohm plus J10 ohm. Now this is V is IZ. Okay, everybody, V is IZ. Now I is, let me write this. Yes, this is 1 sine 100t Z. What is Z? Z is 10 plus J10, na? 10 plus J10. Okay, 10 plus J10. Okay, so now this is however, you see the data, plus and minus 4 Ix and this is the dependent current Ix. Okay, here I am writing, sir, in exam don't write, you can see, but see here now. Now if I do this conversion first, 10 root 2, okay, this is 10 root 2 is how much? 14.14, okay, and angle is 45. So sine of 100t plus 45 is the voltage. I know this is the maximum value, okay, this is the phasor value which is called maximum value. Now if I write a KVL directly, chalo, if I write a KVL, everybody watch the KVL, if I write the KVL directly, minus of 14.14 sine, okay, 100t plus 45, okay, later we will write phasor otherwise, okay, this voltage, plus Ix into, now first let us write all the impedances, 10 plus J10, 10 minus J10, 10 plus J10 plus 10 minus J10, okay, let me write 10 minus J10 here, okay, 10 plus J10 and 10 minus J10, okay, yes, plus 10 minus J10 if I write, okay, everybody, and this is however plus, this way you are writing now, minus 4Ix, minus 4Ix is 0, okay, so if I remove this J operator cancel terms, So you get 20 minus 4, 16ix, okay. So I will say this is like 16ix, okay, 16ix is equal to, you will get this right side, okay, something like 14.14 angle 45, 14.14 angle 45. Now from that ix you will get. But what is Thevenin's voltage? Now once you get ix, that ix is nothing but 14.14 angle 45 by 60. Let it be like that. But what I want, this Thevenin's voltage, Thevenin's voltage is across AB, is ix into this much only, na? So VAB is V Thevenin's. VAB is V Thevenin's, which is open circuit voltage. That is ix into 10 minus J10. So already ix we got how much? 14.14 by 16 angle 45, okay, into directly this if you take, that is again 10 root 2 angle minus 45. Yes, if you observe that 14.14 into 14.14, because 10 root 2 by 16 angle 0, so that much is the magnitude. But if you write in sine terms, so this VTH in terms of sine terms will be, see this magnitude if you calculate everybody, okay, you are getting something right, 12.5, okay, 12.5, that is 14.14 into 14.14 by 16, 12.5, and you will get it as sine 100t, okay, sine 100t. That is what, because original function was sine, na? You see, original function was sine 100t, okay, that is what we got. But now he is asking Thevenin's voltage at, yes, Thevenin's voltage at 5 milliseconds. Now this at t equal to 5 milliseconds, but be careful, now when you are substituting time, make it radians. You cannot have degrees now. If t is given, put it in radians. So put it in radians, that is VTH, you will get it as, yes, 12.5 sine, okay, for 100 into 5 milli, 0.5 in radians if you do, that is 12.5 in radians, you are getting this as 0.4794. Overall you will get it as 6 volts, 6 volts. You are getting integer value, sir. You are getting integer value means accurate. This is really accurate, okay. Okay, this is the answer. So he is asking Thevenin's voltage at an instant. First of all, he gave circuit to reduce. You do source transformation, that is the fastest way, and write a KVL, you will get Ix. Once you got Ix, we got VAB, VTH. But the only difference is Thevenin's voltage at 5th millisecond. 5th millisecond, this is the answer. Wonderful question. Okay, that is a wonderful question. Now let us go to the next question. Now this is a question where I was waiting for, see here it is Y parameters, I will write this neatly. This is the Y parameters he gave, which is like 5 minus 2.5 minus 2.5 and 1 Siemens. Okay, yes, this is the Y parameters, and is asking what is the power dissipated by the load. Now to this Y parameters there is another bridge network, okay, bridge routine network, you can model like that. But actually these two are parallel, na? Y parameters can be added, so that is the simplest way. So if this is the Y parameter of this box, what is the Y parameter of this? Now we know for a series impedance branch, if you write in admittance form, this is 1 by 3 Siemens. And you know there is a shortcut, okay, any network, open circuit is like 0 Siemens, 0 Siemens. So what is the Y parameter of this part? Y parameter of this part alone is, there is a shortcut for pi model in admittance form in Y parameters, where Y11 is 1 by 3, Y22 is 1 by 3. Y12 is minus 1 by 3 and Y21 is also minus 1 by 3 Siemens. Yes or no? Now if you see the total Y parameters, yes, now from this, the total Y parameters are, now Y parameters of this box and the Y parameters of this part. If you see, you add these two, if you add these two, this is 5 plus 1 by 3, okay, 5 plus 1 by 3 is minus of 2.5 plus 1 by 3, okay, and this is also minus of 2.5, that is 5 by 2 plus 1 by 3. And finally it is 1 plus 1 by 3. Okay, now if you simplify, yes, if you simplify, finally you are getting this Y total as, yes, you will get this as 16 by 3. Okay, this is minus 17 by 6, minus 17 by 6, and this is 4 by 3 Siemens. Okay, you are getting this. But sir, finally after getting the Y parameters of this system, now I will write the system like this. So the overall system after reduction has the total Y parameters of what I told there, that is the overall Y total. But he gave the source here and the load here. Source here and the load here. Okay, that is the data what we got. And the source value, how much he gave? 20 volts and 6 ohms. This is 20 volts and 6 ohms. Now what I will do, now we know in two-port networks, this is however V1, this is the positive direction of I1, this is V2, and this is the positive direction of current I2. Now what are the equations we know? I1 is y11 v1, but what is y11? 16 by 3 of v1, okay, plus y12 minus 17 by 6 of v2, and I2 is, yes everybody, if I2 is minus again y21 17 by 6 v1, okay, and then y22 v2, that is plus 4 by 3 v2. These are the two equations from the two systems. That is what is the intention. Here is giving the application of two-port networks. With great difficulty we got y parameters. From y parameters we model the network in terms of two equations. But is asking power here. But what is the data else? What else is the data? V1 is 20. The other data is V1 is directly 20 volts. Okay, that is given. And moreover, if you write a KVL here, Ohm's law. See, in a passive element actually current should enter positive. But it is going ulta na? So V2 is minus. V2 is minus IR. Minus I2 into R. RL is again 6. Now if you see, substitute these two here. Finally to find power I need I2. So finally if you substitute, yeah, V2 here and also V1 here if you substitute. So substitute 3 and 4 into and solve for I2. Okay, you will get this as, okay, if you solve for I2 you will get this I2 as minus 6.296 amperes. But why it came negative? It is true. Because in two-port network, the positive reference direction is this, but answer came negative means actually it is going into the passive element. That is true. That is the meaning. So minus is not a wrong answer, it is correct. It only shows the reference direction as per two-port is opposite to practical. Chalo. Now once we got, what is the power? Yes, power in 6 ohms is this I square R, that is 6.296 square into 6. So we are getting an answer as 237.8 watt. Now out of all the data what I got, I only doubt on the data what we got on this problem, but as per the data, this is the way I solved it. But procedure you follow, sir. Once we get more accurate data, I will give you. But here in this case, this was the only question I was worried about the data. But still, with the data and the options I got from my students, okay, this is the accurate answer I give. Okay, now then we got an outstanding question, sir. Now this is one of the best questions I see. Now this can be related to power systems, machines, okay, and also my three-phase balance systems. And this is the best problem. Okay, now, but I will do detail because so many institutes did not give the solution for it. They are selling the answer, but they did not solve in detail. I would like to do that. Now see here, a balanced delta, okay, this is a delta, he gave like this, but is a delta, I will write like this. So inductor is given, okay, it is actually delta, okay, but R and C, this is also R and C. Okay, so this solution no one is writing, sir. They are just orally telling the answer. All the other institutions, they are orally telling the answer. But they detailed I did, and I want to discuss with you. And how beautiful this problem is. For some beautiful reason, answer will come same as the question itself. But let us prove it. So from the given data, he said this R is 15 ohms, C is 212.21, and LE gave something as 31.38 for 50 hertz. And for 50 hertz, if you substitute in terms of reactance, plus j omega L minus j xc minus j by omega c, you will get this answers as, yes, first this plus j omega L, you are getting this as J10 and J10, okay, and registry is however given 5, registry is however given as a 15, yes, that is independent of frequency, 15 ohms each register, that is also good. But capacitive reactance, if you substitute minus j xc, you will get this as minus j 15 ohms. This is the first part everyone we should do. Okay, you see there are at least 3 to 4 gate bits with the same values in the previous years. For these values at omega equal to 100 pi or 50 hertz frequency, you will get this. So, plus j omega L, you will get this. Minus j by omega c, you will get this. So, now what is asking? If line to line 415 is given, okay, if line to line 415 is given, I will take this as A, B, C. If line to line 415 is given, what is the voltage we get here? Okay, let this be A dash, B dash, C dash. According to the question, this is A, this is B, this is C. So the question you read now. A balanced delta connected load consisting of R and C per phase he gave, given to a total supply of 415 volts line to line with line inductance. So this line has an inductor of this much per phase. Considering the charge in the supply terminal load change, actually it is a change, okay, we got the data from student, we dictated to the typewriters, it is change. Considering the change in the supply terminal voltage to the load to be negligible, the magnitude of the voltage across terminals VAB, this is outstanding, sir. Now what I did, see, to calculate this voltage, in delta it was difficult, so I converted delta to star. Now I converted this delta to star, okay? Easy na sir, 3 equal impedances in delta, the corresponding value in star become by 3. The corresponding value in star become how much? By 3, okay? So if I converted, so this is the circuit it became now, everybody. The impedance of the line also I am writing, plus this part also I am writing. Beautiful sir. But I want to give the accurate answer here. And yes, it is true, it is accurate. And it is true, it is very, very accurate. So this is like A dash, B dash, C dash, and this is point A, this is point B, and this is point C. And this is, however, J10, which is the line impedance he gave, J10, which is the line impedance, and this is like 5 minus J5. Now, why we got this 5 minus J5? Everybody listen now. When we converted this delta to star, impedance become by 3, okay? 15 by 15. Done? Yeah, sorry for the break. Yeah, see, with more data we are getting actually, we are actually sequencing the next faculty. So that is the interruption, I'm sorry for that, but listen now. So, yes, when we converted these 3 equal impedances from delta to star, the star value become by 3. So that is the reason that 15 minus J15 become 5 minus J5. So now he is asking finally this VAB. Now what is this? This is line to line voltage, he gave how much? 415 angle 0. I will take 0. Then what is phase value? In a balanced star now, because this has become star in a balanced star, phase voltage is line voltage by root 3, 415 by root 3, and moreover, phase voltage lag line voltage by 30. If this is 0, this is minus 30, I will do. From that, I will get this IA. IA is the phase current. So IA is the phase current is phase voltage by this, that is 415 by root 3 angle minus 30 by this total impedance. Now total impedance, what I did, this line impedance and also the impedance of the load converted into star. That is, if you add this, total 5 minus J5 plus J10 is 5 plus J5 it becomes. Now you got this current IA as, yes, if you solve, this is 33.88 at an angle minus 75 you are getting. Now automatically the same way, because it's a balanced system, what will be IB? No need to calculate now. What will be IB? It will further lag by 120. So 33.88 lag by 1 minus 195 degree amp. Now what is the question you want? VAB na? This voltage you want. This however neutral, let us say. Now what I will do? This VAB is VAN minus VBN. Now once you got IA, from that what is VAN? VAN is IA into 5 minus J5. And what is VBN? VBN is IB into 5 minus J5. Yes or no? This part and this part, because this is 5 minus J5 here also. But what is VAB? Overall VAB will be VAN minus VBN. So if I do that, yes, VAN minus VBN, if I do that, so we will get this VAB as, okay, that part we will take common, 5 minus J5 if you take common, okay, you will get it as IA minus IB, IA minus IB, okay, if you will get that, you will be getting somewhere around, okay, 5 minus J5, but IA, IB, I gave the values now, sir, you substitute, you will get this as 41.488 minus J, 41.488, and finally you will get this as 415, yes, you will get this as 415 angle minus 90. But he asked only the magnitude, na? This VAB magnitude is 415 volts. It is such an amazing concept that see, supply side also you gave 415, line impedance, line inductance is given here, okay. In the original part you see, this is a transmission line, this is a load. So beauty is the values of R and C are such that, like you know in power system, voltage regulation should be 0. That is sending end voltage equal to receiving end voltage. Here you are giving interesting line to line voltage 415. The values are so cleverly chosen in the exam data that this value is also coming as 415. Only phase shift will happen. But phase shift he did not ask. So That is a beautiful problem, sir. See the calculations. I gave all the accurate calculations. Okay. First, converting delta to star is a trick. Then finding the phase current from this drop. Okay. Then directly writing VAB is VAN minus VBN. So if I take VAN minus VBN, this into IA minus IB. Okay. If I do that, I will get this. So 415 volts is the answer and proof I give. Okay. So my network theory, all 5 questions with most accurate data I give. Only the 2 port I am having doubt. But if values are true, I will also give the accurate data. So all the best. Okay. So don't get panicked, don't get worried with how many marks you get. Okay. We are all there to guide you. Please do come and join with ACE Academy and ACE Online. We are always there to help you. So keep studying. Opportunities keep coming. GATE comes every year. IES comes every year. Genco Transco keep coming. Now next year is election. Yes or no? General election, state and central. So in Telangana. So please, you will have a lot of opportunities. Preparedness. See, I always worry whether student is preparing. What is good luck? See, my sir used to say good luck. Okay, my sir, my guru used to be there in one college. He used to say good luck. What is the correct definition of good luck? Luck won't come to you. Good luck means preparedness plus opportunity. Preparedness plus opportunity. Preparation you do. God will give opportunity. Are you preparing? Now prepare. Even today night, once discussion is over, tomorrow onwards, continue your preparation until next goal you get. Don't stop your preparation. All the best.
Good evening, students. Myself is Satyanarayana, Faculty of ACE Engineering Academy, Electrical Departments. We are going to discuss about the analog questions given in the GATE 2023 electrical paper. So coming to the first question, find the minimum and maximum value of the output voltage. So this is the op amp, given that this is inverting, this is non-inverting term. And the diodes are given. Let's consider this is your diode D1, this is your diode D2. And the signal is applied to the inverting terminal at the output voltage V0. Now as the signal is given to the inverting terminal, the phase shift between these two is 180 degrees of phase. Now, whenever the input voltage, here what asked? Minimum and maximum values of output voltage. As the signal is applied, this is in inverting form. So circuit is inverting amplifier. So your output voltage always depends on your input voltage. When input is maximum, or peak, your output will be maximum only, is maximum or peak value. So whenever the input voltage, when input voltage is plus 100 volts, means during the positive cycle, whenever the input reaches the peak value, what will be the output voltage? This positive potential input is applied, so your output voltage becomes V0 is definitely negative because of 180 degrees of phase shift between the output and input. That negative voltage is given to the N type of diode D1 and P type of diode D2, which makes the diode D2 off states and diode D1 on states. As the diode D2 is off, so this total branch means Zener diode and diode combination becomes off only, so that will be open circuited. As this is open circuited and the diode is ideal, so diode D1 is replaced by short circuit. So your output voltage V0, input voltage Vi, and the resistance R, diode D1. So this is R, this is also R. Now this becomes inverting amplifier. Your output voltage is minus Vi. But as your input voltage is plus 100, so V0 is equal to minus 100 volts. But the supply voltage to the op amp is given plus or minus 15 volts. So as your output voltage exceeds negative supply voltage, so op amp operated in negative saturation region. Whenever it is operated in negative saturation region, your output voltage is restricted to minus 15 volts. So this is minimum output voltage. Minimum output voltage. Similarly, whenever the input voltage is minus 100 volts, when input is negative, your output will be definitely positive value. This positive potential makes the potential at this point is given to the N type of diode D1 and P type of diode D2. So D2 becomes on, D1 becomes off. So diode D1 is off. So diode D2 is in the on state. At the same time, Zener operated in the breakdown region. Then what is your equivalent circuit? Your output voltage V0, this is P type, replaced by negative, N-type is replaced by positive by 5 volts, diode replaced by shorts, and the value of the resistance R and your input voltage Vi. Non-inverting gets 0 potential. Now the voltage at this point is 0. Now V0 is equal to plus 5 volts. This plus 5 volts is maximum output voltage. So V0 maximum is plus 5 volts. V0 minimum is minus 15 volts. So the maximum and minimum values of your output voltage are plus 5 and minus 15 volts. So coming to the next question, this is the circuit is given. Zener voltage is given 5 volts and the current gain of your transistor is 99. Current gain of transistor operated in active region is given. Transistor in active region. That statement not printed here. So transistor operated in the active region. Now first of all, this is directly given your transistor in the active region, but first you have to check your Zener diode. Whether your Zener diode operated in the breakdown region or not, or forward biased or not. For that, now Zener diode is open circuited. So Zener open circuited to check on or off states. So whenever the Zener is open circuited, your circuit becomes your transistor at emitter to ground. What is there? This is 10 ohms. This is 20 ohms. Now here between base and this, your Zener diode is there. Collector is connected to 25 volts. Base of the transistor is connected to collector or to this point through a 7 kilo ohm resistor. Now, current passing through the base of the transistor is IB. Current passing into the collector is IC. Current passing through the emitter is IE. And given the base emitter junction voltage is ignored. Ignored means 0 volts is given in the statement. Now as this potential is 0, so the potential at base and potential at emitter are same. Now, first we need to calculate the currents. So apply KVL in this path. So apply KVL, that is 25 minus drop across 7 kilo, 7 into 10 power 3 IB minus VBE minus 10 plus 20 into IA is equal to 0. 25 minus VBE. VBE is 0, so 25 is equal to 7000 IB plus 30 into IE, 1 plus beta times of IB. As beta is given 99, 1 plus beta is 100, 100 into 30 is 3000. So total becomes 10 power 4 or 10,000 IB. So the value of IB is 25 by 10 power 4, which is 2.5 milliamperes. This is the amount of base current passing through the base of your transistor. Now, as you know the base current, what is its collector current? Which is beta times of IB. So 99 into 2.5 milli, this becomes 0.2475 amperes. Then emitter current is 1 plus beta times of IB, which is 0.25 amperes. Once you know the emitter current, now you can calculate the voltage difference between these 2 points. The voltage difference between these two is nothing but, this is at base of the transistor, what will be their N type? This is N type, this is P type of your Zener. Now we can calculate whether your Vn minus Vp voltage to check your diode, whether in the breakdown region or not. Now, the potential at this point is, let's consider Vn. The potential at this point is Vp. Now KVL between these 2 points, what is that? Vn minus Vbe minus drop across Ie minus Vp is equal to 0. So, Vn minus Vbe minus 10 into Ie minus Vp is equal to 0. So, Vn minus Vp, this is 0, is equal to 10 IE. This Vn minus Vp is 10 into 0.25, so 2.5 volts. This 2.5 volts is less than Zener voltage. So, Zener in the off state. As the Zener is in the off state, now the current passing through the 20 ohm resistor is nothing but emitter current only. So, I is equal to IE only. Now this is 0.25 ampere, but this current is asked in milliamperes, so 250 milliamperes. So the current passing through the 20 ohm resistor is 250 milliamperes.
My name is J. Nageswaram. I am going to discuss the control system subjects. Consider the lead compensator of the form K of S given 1 plus S by alpha divided by 1 plus S by alpha beta. Beta here greater than 1 and alpha greater than 0. The frequency at which the compensator produce the maximum phase lead. That means the given omega m given 4 radians per second given. And at this frequency, the gain amplification provided by the controller, assuming that asymptotic Bode magnitude plot of K of S is 6. That means magnitude at omega m given 6 dB given. 6 dB given. The value of alpha, beta are respectively they are asking. So this is a lead compensator. Lead compensator means first there should be a 0, then there should be a pole. First 0, next pole. What is a 0 here? The 0 is according to the transfer function. 0 is minus alpha. Pole is a minus alpha beta. Pole is minus alpha beta. So now we'll draw a Bode plot for this. So what is the Bode plot for this? So this is magnitude in dB. The corner frequency, first one alpha, second one alpha beta. So see here, there is no pole and 0 at origin, so initial slope is 0. So here 0 dB, 0. So then at alpha 1 0 is there, plus 20. At alpha 1 0 is there, plus 20. Then at beta, one alpha beta, one pole, plus one pole means minus 20 plus 20 becomes 0. This is plus 20 dB for decade. And this is the frequency at which the magnitude they given. This is omega m, the frequency at which maximum phase lead occurs. The omega m they given, that is omega m equal to 4 radians per second given. 4 radians per second given. So omega m is nothing but root of first corner frequency into second corner frequency, that is alpha into alpha beta, that equal to alpha root beta equal to given 4. And then at this omega m they given a magnitude. The magnitude is 6 they given magnitude, that is 6 dB they given. So you can find the year. First year at omega m they given a 6. So use the slope formula. We have to find the what? Alpha and beta values you have to find. You have to find the alpha and beta value. Use the slope formula. Find alpha and beta value. Slope equal to m2 minus m1 divided by log of omega 2 minus log of omega 1. So what is the slope here? Plus 20. Plus 20 equal to. So here the magnitude m2 is 6. m1 is 0. And here omega m. What is omega m? Alpha root beta. And it is a 4. But I'll write it. Log of alpha root beta minus log alpha. Use the slope formula. So then this can be written as log of alpha root beta minus log alpha equal to 6 by 20, that equal to 0.3. So here if you take log common, then alpha root beta by alpha equal to 0.3. Then alpha cancel, and then find the beta value. If you find it, root beta equal to 10 power 0.3. It is approximately equal to 2. So beta equal to 4. So beta equal to 4. But alpha root beta equal to 4. Alpha root beta equal to 4. That equal to alpha beta is 4 equal to 4. then find the alpha value, alpha equal to 2. So alpha 2, beta equal to 4. So the answer is alpha 2, beta equal to 4. Answer C is correct. Next question. So here they given a Bode plot. They are asking the transfer function. By looking the Bode plot, it is given a what? Constant magnitude. That means it is related to the what? Transfer function of just constant, that is g of s, h of s equal to k. But when it is having only constant magnitude, the phase should be 0. But here phase given what? Go on increasing up to what? Minus infinity. That means phase is varying. That means this problem belongs to the transportation delay. We need to add a transportation delay term, that is minus s tau. So now you have to find the k value and you have to find the tau value. To find k, they given a magnitude. So that means 8, they given 8. So shift equal to 8 given. So 20 log k equal to 8 given. So log k equal to 8 by 20. That means 0.4 given. K equal to 10 power 0.4. So its value is 2.51. Its value is 2.51. Next, to find the tau delay, they given the what? Here frequency is 1. So they given the phase angle at frequency. The phase is how much given? Pi. Pi equal to how much they given? Minus 60 degrees at a frequency of 1. That equal to, what is the frequency of frequency of k is 0. Frequency of, the phase of k is 0. The phase of e power minus s tau is minus omega tau. Omega is 1, they given. So this minus minus cancel. 60 means pi by 3. Pi by 3 equal to tau. Its value is 1.047. So that means the transfer function gh equal to 2.51 into e power minus 1.047. Yes. So the answer is A. So here state model they given. They are asking the steady state output will be 0. What is the frequency they are asking? So this state model belongs to the CCF form, controllable canonical form. So we can write the transfer function directly. This is 2 by 2 matrix. The transfer function is like k into B0 plus B1s divided by A0 plus A1s plus s square in this form. So the C matrix gives this is B0, this is B1. So the A matrix gives the denominator terms. This is minus A0, this is minus A1, and this is a k, common factor, it is a k. That means I can write transfer function equal to k is 1. So B0 is 3 plus, here it is minus. So 3, here minus sign is there, so minus 2s divided by, so 1 plus 2s plus s square. This is a d, so plus d, you will get here 1. Here plus d will be there. So 1. So now you simplify this. So what is the transfer function? 3 minus 2s plus 1 plus 2s plus s square divided by 1 plus 2s plus S square, 2s cancel. So then you are getting this 4 plus s square divided by 1 plus 2s plus s square. This is the transfer function. So then you have to find the steady state output you have to find. To find the steady state output, steady state output will be 0 at what frequency they are asking. What is the steady state output? So the given input is what? R of t is sin omega t given. So R of t is sin omega t. You have to find omega value at which steady state output is 0. For example, what is asking? YSS should be 0. So what is y of t? Y of t is just like magnitude into sine of omega t plus pi. So write the magnitude for this transfer function. So s replaced by j omega. So transfer function 4 plus s square divided by 1 plus 2s plus s square we got. S replaced by j omega. So then what you are getting? 4 minus omega square divided by 1 plus j2 omega minus omega square. So if you make magnitude equal to 0, then automatically YSS becomes the 0. So this magnitude, write the magnitude for this. So magnitude, so that means 4 minus omega square divided by 1 plus j2 omega minus omega square equal to 0. That means the omega 4 minus omega square equal to 0. Omega equal to 2 is the answer. Omega equal to 2. So omega equal to 2 is the answer. Next, just they are asking the transfer function. So y by r equal to, there are two forward paths. First forward path is 3 plus second forward path is 2 by s divided by, there is only one loop. So that means 1 minus 1 by s loop gain. So simplify this, 3s plus 2 divided by s minus 1. So that means answer C. Next here, GH given, 3s plus 5 by s minus 1 given. The infinite semicircle arc of the Nyquist contour is mapped into a point they are asking. So if I draw the Nyquist contour for this, so here one pole at plus 1, 0 in the left. If I draw the Nyquist contour, so this is the Nyquist contour. This is plus j infinity. This is minus j infinity. So this is called infinite semicircle. It is called infinite semicircle. This infinite semicircle mapped at the point is they are asking. This infinite semicircle means s should be replaced by r into e power j theta. Theta is plus 90 to minus 90. We don't need phase angle. Just we have to find for the resistance R infinity, you have to find where it is mapped. So S replaced by R into e power j theta. So I can write it as GH into R e power j theta is equal to 3 R e power j theta plus 5 divided by R e power S replaced by R e power j theta minus 1. So here R tends to infinity, limit R tends to infinity here. So that equal to, substitute R tends to infinity means limit R tends to infinity. So what I can write? So 3 plus R, 3 plus 5 by R e power j theta divided by 1 minus 1 by r e power j theta. So r tends to infinity means this is 0, this is 0. So the answer is 3. So the infinite radius semicircle mapped to the point at 3. So the answer is D. Next, consider a unity gain negative feedback consists of a plant 1 by s minus 1 and PI controller given. That means if you draw a diagram, I will draw in the next page. So this is R of S. So here summing point. So here controller, they given a PI controller. So PI controller gain is given, proportional gain is given 3, integral gain is given 1. So that means 3 plus 1 by S, they given, and here given G of S, system given, 1 by S minus 1 given. Then for unit step reference input, the final value of controller output and plant output they are asking. And it is having unity feedback. So that means I will take here C of S. It is having a unity feedback. So controller output, this is called controller output. I will take it as C1 of S I will take. This is controller output. This is plant output. So what they are asking? So final value of controller output and plant output they are asking. So first find the C1 SS they are asking. C1 SS they are asking. So that is nothing but what? Limit t tends to infinity C1 of t. That is nothing but limit s tends to 0 s into C1 of s. Find C1 of s by R of s. So what is the transfer function? Here output we are taking. So the transfer function is 3 plus and 3s plus 1. 3s plus 1 divided by s divided by loop gain 1 plus this loop gain. So that means 3s plus 1 divided by s into 1 by s minus 1. So if you simplify this, what I will get here? SS cancel. So 3s plus 1 into s minus 1 divided by, so if I write here s into s minus 1 plus 3s plus 1. So if I simplify this, I will get 3s plus 1 into s minus 1 divided by s square. Here minus s plus 3s and it will become 2s plus 1. Now find steady state output. C1 SS equal to limit s tends to 0 s into C1 of s. So that means 3s plus 1 into s minus 1 divided by s square plus 2s plus 1 into R of s. R of s given step 1 by s. SS cancel. So s tends to 0 substitute. This is 0. This is 0. So minus 1 by 1 will get. The answer is minus 1. So that means steady state output of the controller is minus 1. Next find plant output steady state. That means C of s by R of s you have to find. So C of s by R of s equal to, so what is the forward path gain? So we can write it as 3s plus 1, 3s plus 1 by s and into 1 by s minus 1. It is having unity feedback. So that means numerator added 3s plus 1. So if we solve this, 3s plus 1 divided by s square plus 2s plus 1. Then CSS if I write. So steady state output of the plant, limit s tends to 0, s into C of s. That equal to limit s tends to 0, s into what is C of s? 3s plus 1 by s square plus 2s plus 1 into 1 by s. Then ss cancel, s tends to 0, s tends to 0, the answer is 1. So this is total 6 questions asked in control system. Next power systems will continue.
Hi, welcome to ACE Online. Myself Krishna Reddy, going to give solutions for power system subject. Okay, let us observe this question from protection part. So he has given a configuration. There is one source feeding two parallel lines, and again there is a radial configuration connected with a load. So what he is asking is which relays are non-directional and which relays are directional. Generally we know that the relays which are connected to the source are what? Non-directional. So this relay will be non-directional. And for this parallel feeder B1, these two relays are also what? Non-directional relays. These two are non-directional relays. Whereas these two relays will be the directional relays. B3 and B4 will be the directional relays. Remaining all are what? Non-directional relays, because there will not be any change in direction of current from normal condition to fault condition. So the relays which are directional are what? B3 and B4 are directional relays in this configuration. Okay. So directional relays are what? B3 and B4. Now let us observe this question. So this question is from economic aspects, economic load dispatch. So he has given the fuel cost of 2 plants, and he has given the demand of 290 megawatt, and he is saying that for this 290 megawatt, PG1 is 175 megawatt and PG2 is 115 megawatt. So he has already provided the solution. What he is saying is, if A is increased by 10%, okay, this in this equation he has kept one unknown term, that is, if A is increased by how much? 10%, then what will be the fuel cost? So here, if you can go for dF1 by dPg1 must be equal to what? dF2 by dPg2. So this is a condition for economic scheduling, yes or no? So here line losses are not mentioned, so line losses are neglected. So from this we will get the value of A. Now automatically here what he is saying is A value is increased by how much? 10%. So as A value is increased by 10% and we need to maintain this dF1 by dPg1 same as dF2 by dPg2. So automatically the PG1 value should be decreased. PG1 value should be decreased and PG2 value will be increased. PG2 value will be increased in this configuration. Okay. So and the fuel cost will be increased and the fuel cost will be increased here. So once we get these values, we will get the values of, we observe that the fuel cost will be increased. Okay. So this is a part from protection as well as economic load dispatch. Now my colleague will continue with the remaining questions.
Welcome back, students. Myself Prasad Megavarna. So I'm going to continue the remaining power systems questions here. So this is the question from transmission and distribution we are having, and already we have discussed this type of problems a lot in the classroom. So here, just read the question here. They have given a 50 Hz 275 kilovolts line of length 400 kilometers has the following parameters: resistance given, inductance given, and the capacitance of the line are given. Right, so capacitance of the line means it is the shunt capacitance, right? So that is the line to ground or line to line capacitance, line to neutral capacitance you have to calculate. So the line is having series resistance and series inductance and the shunt capacitance, right? The line is represented by the nominal pi model with the magnitude of sending end and receiving end voltage of line directed by Vs and Vr respectively. Now, the receiving end voltage is also maintained at 275 kilovolts. The phase angle difference theta between Vs and Vr. What is the phase angle difference between Vs and Vr, right? So required for maximum possible active power transfer, just look at here, students. They are given a simple power system network. Here we are having 2 buses. This is bus 1, this will be bus 1 and this will be bus 2. Bus 1 and bus 2. At bus 1 we are having a voltage of Vs and bus 2 we are having a voltage of Vr, and if Vr is the reference 0, then Vs is having an angle of delta, we normally call it as, and they have given it as theta. They have given it as theta. But normally, so in our class discussion we have taken it as delta. Clear? So here they have given it is theta. Now from these equations, for a lossy transmission line, whenever the line is having an impedance of Z, the lossy transmission line is having an active power transfer equation PR. PR is nothing but Vs Vr divided by Z. Vs Vr divided by Z cos of, actually here you have to write delta minus theta. Delta minus theta. In place of delta they have given theta, and in place of theta we are going to write as phi. So where phi is the impedance angle, theta is the delta. Just remember, students, so normally in the class, in place of theta, we have taken it as delta, and in place of theta, we have taken it as, that is, in place of phi, we have taken it as theta in the classroom. But no need to confuse here, just check here, based on the data given, we are changing the notations, that's only. But the formula remains same, Vs Vr divided by Z, cos of theta minus phi, minus Vs Vr divided by Z, cos phi. Cos phi. In place of theta I am writing phi. Clear? So in this equation, what is the condition for maximum power? To get the maximum power, the positive term should be maximum, right? To get maximum power, what is the condition? What you have to write here? Theta is equivalent to phi. What is phi? Is equivalent to tan inverse of XL by R. XL by R. The related data they have given already, right? So what is XL? So XL is nothing but omega L, frequency is given, and the line inductance is also given, the line resistance is also given. We have to calculate the value of theta, right? So just substitute that where theta is equivalent to tan inverse of omega L divided by R, which is nothing but tan inverse of 2 pi into 50 into L is given 1 millihenry. So 1 into 10 power minus 3 divided by the resistance value is given. So what is the resistance value they have given here? The resistance value they have given here, it is right. So it will be the resistance value they have given, it is 0.035. 0.035. So if you calculate this one, we will get the theta value 83.64 degrees we can get. That is the exact value we are having. So this is the first question, and so we are having one more question here. It is one of the most important question. So already we have discussed this type of questions a lot in the classroom. How to classify the buses in various ways we have discussed it in the class, students. Just check here. Here they have given one bus by representing the generator here. Here they have represented the generator. By representing the generator, they have given the P2 value as 200 megawatt, and Q2 value they have given 40 MVAR. 40 MVAR. And next thing, they have represented one more bus here, and they are saying that this is infinite bus. For infinite bus, they have given the quantities as, so it is V3 at an angle of delta 3, theta 3 or theta 3, they have given it as 0.1 at an angle of minus 15 degrees. And in the next line, they have represented one more bus here. Here they have connected a controlled current source. Given the numberings, this will be bus 1, and this will be bus 2, and this will be bus 3. These are the three buses they had given. And they are asking that what is the bus classification. Just check here, at bus 2, they have given generator only. But what are the specified quantities? That you have to remember here. What are the specified quantities? The specified quantities are P2 and Q2. Right? At any bus, P2 and Q2 are given, and the load is not specified. We can take that at that bus, the load quantities are 0. So that at bus 2, what you are having? P2 is PG minus PD actually, generation minus demand. Totally they have given it as 200 megawatt. So that it is known. And Q2 they have given 40 MVAR, and it is also known. So here these are known, so that it is a PQ bus. And at bus 1, please check it here. At bus 1, what they have specified, it is infinite bus, and the specified quantities are voltage and its magnitude, its angle they have given. So that Here voltage magnitude V3 is given 0.1 per unit and theta 3 is given minus 15 degrees. These are known. These are known. So that when V3 and delta 3 are known, then it is called as a slack bus. It is called as a slack bus. Remember students? So in the classroom itself we have discussed that for a slack bus the angle should be the reference angle. Normally we can take it as 0, but there is no condition that every time you have to maintain 0. Clear? So whenever if you are taking 0, that will be good, but there is no condition, definitely you have to take it as 0. Clear students? And one more bus they have given, it is the controlled bus. At controlled bus they have given the voltage magnitude value. The voltage magnitude value they have given here, it is V magnitude. They have specified it is 1.05, and the value of theta, they have theta 1 they have not given. They have not given, and they have not specified the PG value and QG value and PD value and QD value. See here at this bus, at bus 3, at bus 1, at bus 1, this is bus 3 students. This is bus 3 at bus 1. At bus 1. Please check here. PG is 0, PD is also 0. QG is also 0 and QD is also 0. QD is also 0. And they are controlling the voltage. Whenever they are controlling the voltage, automatically the reactive power will become variable. The reactive power will become variable. Here P is known. P is known, and they have given the voltage magnitude value as 1.05. So that P and V are known. So that it will be a PV bus. PV bus. Therefore, we can say bus 1 is a PV bus and bus 2 is a PQ bus and bus 3 is a slack bus. Right? This is bus 3, not bus 1. This is bus 3. Clear? So, these are the quantities. At bus 1, what you are having? At bus 1 PV bus, at bus 2 PQ bus, at bus 3 it is slack bus. That's what we are having here. This is the question from the bus classification we are having. And if you see one more question here, so this is the question based on the line to line fault they have given students. So just the 2 bus power system shown in the figure has alternator supplying synchronous motor through a star delta transformer. So the total diagram they have given here. This is the diagram of the system. And from this one, whenever there is a fault, whenever there is a line to line fault at bus 1, then what is the fault current in per unit they are asking. Very simple question students. The fault current for LL fault, it will be root 3 times of the pre-fault voltage, which is nothing but EA1 divided by Z1 equivalent plus Z2 equivalent. And the line to line fault never depends upon the zero sequence network, so that no need of the zero sequence network. This is the positive sequence network with sources. This is the negative sequence network without the sources they are given, and in case of the zero sequence network, no need of the zero sequence network for the line to line fault. Therefore, from this one, there is a fault at bus 1 here, there is a fault at bus 1 here also. Therefore, if you calculate X1 equivalent or Z1 equivalent is nothing but, so it is 0.1, it is also J0.1, it is J0.2 parallel to J0.3, it will be J0.12. And whereas Z2 equivalent is also equivalent to J0.2 parallel to J0.3, it will be J0.12. And the magnitude of this current, it will be root 3 divided by J0.12 plus J0.12, 0.12. If you calculate, approximately 7.2 per unit is the magnitude of the fault current for this fault. Clear? So this is the one of the very easiest question they have asked, and you have to do it very simply. Clear? And so if you see one more question here, so this question they have given based on the Y bus formation. So in case of the Y bus formation, they have given the bus admittance matrix like this. It is very simple question. Already we have discussed this type of questions here. Minus J15, J10, J5 and J10 minus J13.5, J4 and J5, J4 and minus J8. This is the Y bus they are given. Please check it students. And they are asking that where we are having the line charging admittances and the shunt capacitors. See here, the line charging admittances are existed in the lines and shunt capacitors are connected at the buses. Clear? They are asking in the question that in which line we are having the line charging admittances and at which bus we are having the shunt admittances. First of all, to identify the shunt admittances, we have to add the rows or the columns. So whenever you are adding the rows or the columns, so whenever you are adding the row, in this row there is no shunt element. But in this row, we are having a shunt element of what is the total admittance we are having? It is plus J 0.5. So that there is a capacitor. There is a capacitor. And here also, in this line, it will be plus J1. So that there is a capacitor here. But we have to resolve the network into shunt admittances as well as the line charging admittances. Just remember here, we are having 3 buses, students. All the 3 buses are connected. This is line 1, this is bus 1 and bus 2, and this will be line 2 between buses 2 and 3, and this will be the third line we are having between buses 1 and 3. Please check it, students. At bus 2, they have connected a capacitor of what? Suppose we are assuming that this is a shunt capacitor of J 0.5, and at bus 3, suppose we are assuming that there is a shunt capacitor of J1 for example. Now, from the options they have not given that at bus 2 and bus 3 we are having shunt admittances. But from the options they are assuming that between buses 2 and 3 or 1 and 3 or 1 and 2, whatever it may be, you have to make one line which is having the line charging admittances. The only possibility here, so connect this 0.5 here, that will become line charging admittance, and in this also exactly half amount. How much amount have connected here? The same amount connect here, so that that line will become a nominal pi model. In that nominal pi model, we are having the line charging admittances. If you check here, in this we are having, this is line 1, this is line 1, this is one line between buses 1 and 3. Here, I am connecting one capacitor here of J 0.5, and here line is having some impedance, and here also J 0.5, and here we are having remaining half, what is that? J 0.5. If you check here, where we are having the line charging admittances, between buses 2 and 3, we are having line charging admittances, and at bus 3 we are having the shunt capacitor. Please read the question carefully. They are asking that which is not true there. Which is not true, they are asking. So that from the options, so option A, the line charging capacitance of finite value is present in lines 2 and 3 only, and shunt capacitor is present at bus 1. So that which is not correct statement. This is not correct. So we need the not correct statement, so that this is what we need. This is MSQ question, students, multi-select question. So this is one of the option we can prefer. And in the second option, the line charging capacitance of finite value is present in lines 2 and 3 only, and shunt capacitor of finite value is present at bus 3. So that this is the correct one. This is correct statement. But we don't want this one because they are asking which are not true. And the next statement, line charging capacitor of finite value is present in all the lines, which is not correct statement. Which is not correct statement, and it is true. It is the required answer for this one. And one more statement, line charging capacitor of finite value is present in the lines 2 and 3. So that it is correct statement, but we don't want this one. So that what are the options we are having? Option A and option C. A and C are not correct. Not correct. And those are the answers for this question. Clear? So these are the questions we are having from the power systems point of view, right?
Yes, good evening all of you. Okay, so almost every question is easy, but what is the only thing here why people felt difficultness in the examination is the way of question creating. Let us consider maybe there are two questions like that. It is little lengthy questions. It looks, so once we see the question, just by looking at the question we get fear. Okay, but if you read with patience, nothing is there in that, so easily we can solve all the questions almost. Let's see one by one from machines. See the question. This is an induction motor, a 10 pole 50 hertz 240 volt single phase induction motor runs at 540 rpm while driving rated load. The frequency of induced rotor current due to backward field. Generally in single phase induction motor we have two fields, forward and backward. Generally we operate with the forward slip, but here they are asking about backward field. So when there is backward field, we have backward slip. But in three-phase induction motor, we have only forward slip. But here we have backward slip also. So whenever they ask backward slip, so we need to find accordingly that rotor frequency. First, what is the rotor frequency under running condition? Is equal to S into F. If it is forward case, forward slip. Backward, due to backward field, we find backward slip and backward frequency we get in the rotor current. Frequency due to backward field. Now here we need backward, that's why SB into F. Now what is SB? Backward slip is Ns plus N divided by Ns. Or in simply way, you can also take 2 minus S. 2 minus that forward slip S. So what is slip formula? Ns minus N by Ns. But backward slip directly I am writing Ns plus N by Ns. Because rotor rotating led clockwise, backward means the field will be rotating opposite direction to that. Then what is the resultant speed? Sum of that two. Now it is given here 10 poles 50 hertz. For 10 pole 50 hertz, what is the synchronous speed? 600 rpm. So directly substitute here. Ns equal to 600 plus motor running at 540 rpm divided by synchronous speed. So it will get 1.9. Okay, so this is backward slip. Now substitute here 1.9 into 50. So the answer will be 95 hertz. Generally, if you have general idea, no need to solve this question also. Directly from options, you can able to answer this. Generally, forward slip will be very less. In the range 2 hertz, 3 hertz, 4 hertz like that will be there. Okay, so this is not this much low. Backward slip will be near to double always. So almost 98, 96 in that range will be there. From given options, we can say it is 95 directly. Okay, next question. See the question on DC motor. A separately excited DC motor rated 400 volts, 15 amperes, 1500 rpm. It is driving a constant torque load. So what is the condition in this question? Constant torque is the condition. Okay, it is running initially at 1500 rpm and armature current 15 amperes, supply voltage 400 volts. Now at a rated speed, operating from 400 volt DC supply, drawing rated current. This is initial data. Now the armature resistance 1.2 ohm. If the supply voltage drops to 10% with the field current unaltered, means field current constant, means flux will be constant in this, flux is constant, voltage drops to 10%. So just voltage control, whenever voltage reduced, definitely speed also reduced. Okay, speed will be reduced now. We have to calculate what is the new speed. Let N1 is 1500 rpm. Initial armature current given, so directly I am writing back EMF V minus IA1 RA. This is V is what? 400 minus armature current 15 amps rated current given, 15 into armature resistance 1.2. So calculate, we get 382 volts. So this is initial back EMF. Now what is the new voltage? 10% drop. Now EB2 will be V, new voltage is 10% drop, so remaining is 0.9 V minus IA. If it is IA1, what is IA2? So as torque condition is given, we know that torque is proportional to product of flux and armature current. Field current constant, so flux constant. In order to have torque constant, armature current also should be constant. So current remains same, IA2 also same current. Resistance will not change. Now substitute here. We get 0.9 into 400 360 minus armature current 15, armature resistance 1.1. So we'll get it is 342. Okay, 342 volts. This is the back EMF. Under second condition, after reducing voltage. Now, what is the back EMF always? Proportional to speed and flux. EB proportional to N phi. Flux constant here. So directly N2 by N1 is equal to EB2 by EB1. Now, what is N2? N1 is 1500, EB2 342, EB1 382. Now, solve this, we get around 1342.9. So, approximately 1343 I am taking. Okay, so this is the new speed of motor after reduction of voltage by 10%. Clear? Next question. So, given matching here with respect to induction motor. So, simply here with respect to induction motor, generator mode given, motor mode given, braking mode given, plugging nothing but one of the braking. So, you should know what is the range of slip in induction motor for all these regions. For induction motor, the slip range is 0 less than S less than or equal to 1, but not equal to 0. 0 to 1, 1 is there, but it never be 0, okay? Slip never be 0 for induction motor. Now, in the induction generator, slip always less than 0, or you can say negative it is. Negative, not equal to 0, less than 0. Because N greater than NS we rotate. Next, braking operation. For braking operation, the slip will be greater than 1. Greater than 1. Now, if you know this data, you can answer this match easily. Generator mode slip negative, only one option is there here, that is R. It is matching with this -120, negative slip it is. Next, running motor mode. Motoring always 0 to 1. 0 to 1 is this. So, A, R, B, P, next Q, C will be with Q. So, A, R, B, P, C, Q. Option D is correct. Okay. Next question. See this question on synchronous motor. A three-phase synchronous motor with synchronous impedance 0.1 plus J 0.3 ohm per phase, per unit given it is, per unit per phase, has static stability limit. So, static stability limit is nothing but maximum power developed. So, maximum power developed is this much, 2.5. Next, the corresponding excitation voltage. So, for this question, you should know only what is the maximum power developed by separately synchronous motor. Maximum power developed by synchronous motor is what? What is the equation? Maximum power is EV by ZS cos theta minus E square by ZS minus E square by ZS. So, this is the equation. Maximum power developed by DC motor. And this value they given, how much? 2.5 equal to EV by ZS. So, as it is connected to bus bar or infinite bus bar, infinite voltage, let us consider this voltage is 1 per unit. Now, we need to find excitation EMF E here divided by ZS. What is magnitude of ZS? ZS equal to root of R square plus X square. So, we get 0.316 and also find theta, tan inverse X by R. So, we get it is 71.56. Okay. EV by ZS minus E square by ZS cos theta it is. E square by ZS cos theta. So, substitute here. E is, we need to find EMF. ZS is 0.316 into minus E square, unknown it is, E square divided by ZS is 0.316 into cos theta, cos of 71.56. Okay. Now, if you solve this is a quadratic equation, ax square plus bx plus c. Now, if you solve this equation, we get two roots here. So, we are getting two values, one is 1.53 and another one 1.63. So, let us see what will be the answer for this exactly. Okay. Next question. See the next question. A 3-phase 415 volt, 50 hertz 6 pole 960 RPM, 4 HP squirrel cage induction motor drives a constant torque load. At rated speed, operating from rated supply and delivering rated output. So simply here the question is, if from here see, if the supply voltage and frequency are reduced by 20%. So here both voltage reduced and frequency also reduced. Now which speed control method? V by F speed control method. So as V by F is constant, we need to find the resultant speed of the motor. So torque is constant and V by F control ratio is constant. Then what is the relation? Ns minus N equal to constant. Ns minus N. Slip speed is constant. Okay, so use this condition in two cases. Ns1 minus N1 is equal to Ns2 minus N2. So Ns1 means initially. What is the frequency and poles? Poles are fixed here, 6 pole, 50 hertz. What is the speed for 6 pole? 1000 RPM. Now it is rotating at what speed? 960 given. This is equal to Ns2. So voltage and frequency both reduced by 20%. So frequency 20% reduced means 10 hertz reduced. Then remaining 40 hertz. So 120 into 40 divided by 6 minus N2. So we need to find that speed here. So if you find the speed, we get 760 RPM. Okay, so this is the new speed of motor. See the next question. So this question is general question for rotating machines. It is not for specifically DC or synchronous like that. So just read the question. Question only lengthy here. But if you see the figure, we need to find according to figure. So simple the question is, they given 4 conductors here, A dash, B dash, with respect to this current direction. This is cross, here dot, here cross, and here dot. And we need to find what is the EMF induced in the coil A dash and B dash. What will be the EMF from given options? So first of all, according to right hand thumb rule. So this question depends on 2 rules. One is right hand thumb rule and Fleming's right hand rule. So if you apply these two, you will get the answer easily. Now with respect to right hand thumb rule, here cross, flux will be rotating in this direction clockwise, and this is dot anti-clockwise, and this is cross clockwise, flux is moving, and it is dot, flux is moving anti-clockwise. Okay, like this. Now if you see here adjacent to each other, the flux is moving in the same direction both, and here also flux is moving downward, so both are moving in same direction, and here also it is down, it is also down, flux is moving towards this, and here similarly flux is moving upward towards outside. Okay, like this. Now based on the flux direction in between the conductors, poles will be formed. Now what is the pole formation here? North pole will be formed, because flux is coming out of the core. Flux coming outside means what? If you take a magnet, flux will come from north pole outside. So this is north, and here south will be formed, here north, and here south will be formed. Now if you apply Fleming's right hand rule, given question is rotor is rotating in clockwise at some omega radians per second. Rotation is clockwise direction. Now this is the flux direction, 4 finger. Thumb indicates motion of conductor. This is flux, and motion of conductor towards clockwise means downward here, and in conductor A we get cross, here we get cross, and A dash if you apply. So whenever it is rotating, the current in A dash we have to find. So you see here, it is under this north pole whenever it rotates. So this is flux direction, and motion of conductor towards this, and middle finger going inside here. This is also cross. Now what is the resultant EMF in the coil A? If it is positive here, plus minus, here also we are getting same plus minus. So what is resultant voltage? 0, because of similar poles here. That's why this is 0, this is also 0. Okay, so option B is correct. last question. So here this question looks very lengthy, but try to read the question with some patience. You can solve it easily. So based on the available data, we can able to solve. So let's see what will be the exact data after releasing the question paper. So here, when the winding CD of the single phase 50 Hz 2 winding transformer is supplied from AC current source of frequency 50 Hz at rated voltage 50 Hz. So this is given secondary side CD. In the winding CD, there is a current source of frequency 50 Hz and a voltage, rated voltage of 200 volts and 50 Hz obtained across the terminals AB here. Just like it is, you can consider it is source side and some current source is given on other winding, but no use of this current source here. So we need to find finally in the question the self inductance of the winding AB, and they given some leakage impedance of AB and leakage impedance of CD, and there is some core cross section. Core cross section area is 500 millimeter square, and the length of the core is 500 millimeters, and maximum density is 1 Weber per meter square. Okay, and this voltage is RMS voltage given. So what is the equation of RMS voltage? EMF, let E1 it is, I am taking AB E1 equal to 4.44 Bm AN F N1. Now here density given, cross sectional area given, substitute all the data here, 200 volts RMS given, 4.44, flux density is 1 Weber per meter square, net area is 500 into 10 power minus 6 millimeter square, and frequency 50, number of turns unknown here. So let us find number of turns N1. So it is getting around 180 turns. So these are the turns in AB. But we need to find here self inductance of the winding AB in millihenry. What is the formula for this? The self inductance, let L1 equal to, what is the formula? N1 square divided by reluctance. And what is formula for reluctance? L by mu A, length of the core, cross sectional area and permeability. Given L is 500 millimeters into 10 power minus 3. Permeability mu naught into mu R, 4 pi 10 power minus 7 into relative permeability is given 5000. 5000 it is. Into cross sectional area is 500 millimeters square, 10 power minus 6. Okay, substitute here. L1 equal to, so I am writing directly, 180 square into 4 pi 10 power minus 7 into 5000 into 500 10 power minus 6 divided by L is 500 millimeters, 500 into 10 power minus 3. Now solve this equation, we will get the self inductance of the winding AB. So this value I am getting around 203.5 millihenry. So this is in millihenry they asked, that's why it is 203.5 millihenry. Okay, so this is the answer for this self inductance of the winding. So these are the questions from machines.
Hello friends, let us see the questions which are related to the electromagnetic theory. There were 2 questions so far we have collected. Okay, this is a question. It is something related to the charge which is in the presence of both electric and magnetic field. Just read out in the figure the electric field E and the magnetic field B pointed in the x and z directions respectively and have a constant magnitude. A positive charge Q is released from the rest. Initially it was rest at the origin. Which of the following statement is or true? It is a multiple select question asked for 2 marks. Okay, fine. Now for this one you should know some conclusions here. Directly there is some out of derivation there are some conclusions. The conclusions here are, suppose if I shoot a charge which is along the direction of electric field, the charge will going to pick up some acceleration.
Suppose if I charge perpendicular to the electric field, it will go into take a parabolic path. Suppose if the charge is along the direction of magnetic field, it will going to pick up no acceleration. Suppose if the charge is shoot exactly perpendicular to the magnetic field, it will going to pick up a circular path. Suppose if I shoot a charge which is making some certain angle with respect to the magnetic field, it will going to pick up helical path. So these are the conclusions out of clubbing the electrostatics, magnetostatics and kinematic equations. Let us see what conclusions you can draw from here. See here, let me redraw this question one more time. So let me turn the page here. So here is a magnetic field. Here is a coordinate system. Here it is x-axis, y-axis, and then z-axis. Magnetic field is oriented in the x direction. That means the magnetic field is like this. So this is in the x direction, and the electric field is in the z direction. Remember, the charge is at the origin, and it has initial velocity is 0. Fine. Let us take at time t is equal to 0 or initially. At time t is equal to 0 or initially, what is the electric force? The electric force is given by a Q into E, which you can equate it to the mechanical force. Fine. So what is the acceleration? It is Q into E divided by m. Fine. So within no time, at time t is equal to 0, and one more thing here, it will not going to have any magnetic force. Only at time t is equal to 0, it will going to have only electric force. Okay. Fine. So what is the magnetic force? Why? Because the magnetic force is equal to Q into V cross B. Correct? Okay. So initially it has got no velocity, so this will be equal to 0. Why? Because the initial velocity is 0. So it will going to pick up some acceleration. So it will going to have some velocity. At time t is equal to 0 plus, I can say, what is the velocity it will going to have? The velocity is equal to acceleration into time. It is a vector quantity. Fine. What is the acceleration here? Q into E by m into t. Remember, this electric field is in which direction? This electric field is in the z direction. Fine. So when the charge picks up some velocity at time t is equal to 0 plus, so it is in the presence of both electric and magnetic field, you can apply the Lorentz force relation. So F total force is equal to Q into E plus V cross B. Okay. So what is the electric field direction? Electric field is, I'm just looking at the direction. Okay. I'm not going into a rigorous mathematical proof for this one. So the electric field is in the z direction. Here the velocity, it is in the electric field. Electric field is a z. Cross magnetic field is in the x direction. So what is the z cross x? Z cross x is y. That means the charge will go into move in the yz plane. You can notice here it is a yz plane. So the charge will go into, that means, so it will go to turn like this. Why? Because the magnetic field is like this. Since it is picking up some velocity, it will go into circulate in the circular manner. It is something like this. But what happens, you can show this one, this will going to be like this. It is called cycloid path. Okay, we will not go into the derivation part. Let us see how the charge, what is the charge it is picking up. Okay, so the trajectory of the charge will be circle. No, it is not circle, it is a cycloid. Okay, the charge will progress in the direction of y. No, it is not only on the direction, yes, it is the direction of y. Just a second. It is the direction of y. Charge will always move in the yz plane. It's not only on the y, it is in the xy plane. Just a second, where it is? It is in the yz plane. The charge will move in the direction in the direction z with a constant velocity. No, it is actually, there is some you should get here, you should get which plane it is. It is a yz plane. Actually the options was, it is a yz plane. Here it is. Okay, why? Because it is in the yz plane. Fine. So last option, this is not correct. It is not correct. It is not only moving on the y, it is in the both y and z. And option D, the charge will move in the direction z with the constant velocity. Let us see. It is not moving in the it is not moving in the z direction. That too, it is not a constant velocity. The velocity is changing with respect to time. So this option is also wrong. Okay, small printing mistake. Here it is a yz plane. Clear? So this is all about this. Let us have one more question. It is a directly formula based question. So here, let me draw this one little bit bigger one. So here it is x-axis, y-axis and then z-axis. Clear? So infinite current sheet is placed on z is equal to 0 plane. That means the infinite current sheet, the diagram is provided, I think. Okay. So how much is the current here? The current here is 5x cap ampere per meter. Is asking what is the magnetic field intensity at 1, 1, 1, 1, 1, 1. So the 1, 1, 1 is somewhere here. Okay. Suppose what is the formula for this one? H is equal to, there is a direct formula, the magnetic field due to infinite uniform sheet current. Fine. So n by 2 cross n cap. So you want a point here, you want a magnetic field here, then the normal for the sheet will be in the z direction. Suppose if the point would have taken below the sheet, then the normal would have been the minus z direction. Fine. So H is equal to, it is 5x cap divided by 2 cross the normal to the sheet at the field point is this one. It is 2.5. X cross z is minus y cap. Fine. So it is minus 2.5 into y cap. I think answer was numerical answer type. He was asking only the magnitude. So what happens to the magnitude of the magnetic field intensity? It is 2.5. Units are ampere per meter. And one more point, the point doesn't matter whether you take above the sheet or below the sheet, the magnitude of the magnetic field intensity remains same and it is independent of the distance due to infinite uniform sheet current density. Okay, fine. So this is the answer for this. These are all about the questions which are related to the electromagnetic theory.
Hello my dear friends, let us go ahead with the numerical ability question solutions. See the first question, they given regarding this area, okay, geometry, coordinate geometry, they given clearly in the syllabus, they asked the question from that area as well. See the first question here, we have a square, this is a square shape, okay, this is square, not rectangle, square shape, and we have two semicircles, this is a semicircle, this is one semicircle, two semicircles, both having same diameter 6 centimeters and 6 centimeters. Clearly from that we can understand this is actually a square sheet with two semicircles. Here one semicircle and this is one more semicircle. What is the question they are asking is you have to find this shaded area. See this area, we don't want to calculate this part in between, that they don't want, they want only this area, right? See guys, okay, how to calculate this shaded area is, first I am calculating these two circles area. This is one semicircle, this is one semicircle, adding will get total circle, right? So this area, this total area I am calculating, then I will remove this part, this common, this middle part will be removed. Okay, from these two circles adding and then you remove this A part, okay. Now this is circle, two combined, two semicircles with same radius combined will get one circle. So that is nothing but pi r square as radius equal to 3. See here, diameter is 6, radius is 3. So we'll get it is nothing but 9 pi. 9 into pi is this two circles area, right? But I want to remove this. This A is common in first semicircle, this A is common in second semicircle. I want to remove this 2A. In fact, 2A should be removed. 2A should be removed from this part. Then only shaded area, this, only this shaded part they want. Okay, not this entire, this area they don't want. Remove this. So this A is common in first semicircle, this A is common in second semicircle. I have to remove 2A. Your task is now to calculate 2A. See, one simple idea is we can take okay, we know entire circle. Okay, let's go ahead with the entire circle, then we'll get back to this entire scenario. Yeah, we have a circle entire. One moment. We have an entire circle. So this is 1/4 part of that circle, right? Now here, if we draw a line, we got a right angle triangle here. This is with radius 3. Okay, circle with radius 3. This is nothing but, okay, right angle triangle, half into base into height, which is nothing but 9/2. Now if you consider this part, this quarter part, 1/4 of that, this is entire circle. Okay, 1/4 part is this. So entire circle is 9 pi, we already know. This part is nothing but 9 pi by 4. Among that 9 pi by 4, okay, this right angle triangle is taking 9/2 area, right? Now this is what A, you know, the one which we are mentioning A in previous year, not only A, half of that A. This half part is covered. This is A/2, I can say. This area whatever you have here, this is A/2. A/2 is nothing but 9 pi by 4 minus 9/2. A/2 part, you observe, this is entire A. I'm covering this part. I'm just speaking about half of this. So it's A/2. I want 2A to be removed. So A/2 is nothing but this. You want 2A means you should multiply by 4. When you multiply by 4, 2A will be nothing but 9 pi minus 18. 2A will be 9 pi minus 18. Now finally, I want shaded area. Shaded area is nothing but this total 9 pi minus 18, you need to subtract, we'll get 18. Right? So this is regarding that area, shaded area part. This A should be removed, that you have to be checked once and twice. Okay. Now see the next question, units place, very repeated question related to number systems topic. We know 2378 is having cyclicity 4. When it is cyclicity 4, we should divide the power with 4. For dividing power with 4, last 2 digits is sufficient. No need to take the entire number. Among 3 power 999, divide 99. When you divide 99 with 4, remainder is 3. We have to divide power with 4. Cyclicity 4 is that. Divide power with 4, take the remainder. As remainder is 3, last 2 digits sufficient. Okay, put here. Sir, 1000 is divided by 4. When the number is divided by 4, put the power as 4. We've taken a common point during your regular sessions. When remainder is 0, take as power as 4. Okay, so now 3 power 3 is nothing but 27. Units place is 7. 7 power 4 means 7 square into 7 square. 7 square means units place 9. 9 into 9. 81, 1. So we'll get 7 into 1, 7. This is a very regular question regarding unit space. So answer is 7 here. They're given fill in the blank. They're given a MCQ. They can give fill in the blank also. This type of questions. Next one, number of triangles. Okay, you know, this is there in your booklet as well. You can check. Number of triangles in this, we're given a shortcut like you have to write 1, 2, 3, 4. Okay, double is the total number of triangles, 4 into 2, 8. In this shape, 8. Okay, now, and you have one more thing, like this if you have, this, here also we're given shortcut. Here 1 and 2, 1 plus 2 is 3. If the shape is like this, 1 plus 2 adding. If the shape is like this, write 1, 2, 3, 4. Last number double is the number of triangles. So in this shape 8, in this shape 3, you observe this first one. In this shape you will get 8. In this bigger one if you observe, okay, that is 8 actually. Okay, 8 plus every corner you have this shape, 3. So 4 corners, 3 into 4. We got totally 20 here. You observe this. If this is the shape, okay, you can take A, B, C, D, you can count manually as well. Okay, but I'm just giving the trick. Last number double, 8. That's what you can observe in this bigger shape with into mark. Then every corner you observe, we got 3 triangles.
every corner 3 triangles. As you have 4 corners, 4 into 3, 12. So 8 plus 12 is nothing but 20. Number of triangles is 20 with the trick what you discussed in regular sessions. Next question they given related to probability. When 2 dice are thrown, we know total is nothing but 6 into 6, 36. And here they clearly given, so the first one should appear on the first die. Okay, top of the face, one number is appeared. That should be 1 on the first die. And second one is 4. That's only one chance. Favorable is only 1 here. Total 36, you know, that is 1, 1, 1, 2, so on up to 6, 6. Here favorable is only 1. So we can say probability favorable out of total 1 upon 36. Or else we can do that as an individual event, first one separately, second one separately. Or you can go ahead with 2, both together also, okay. And see guys, okay, here they given antonyms related to verbal ability. Enforce and relax, this is antonym. And for permit, the antonym is nothing but forbid, right? So we collected around 5 questions related to general aptitude. We discussed those. Okay, maybe once entire paper is released, we'll give the remaining questions full discussion as well. Thank you, dear.
Hi, myself P. Venkatrao. Now I am going to discuss the questions what I have received from the students. So we see probability. The question is expected number of trials for first outcome of head for a biased coin is 4. That is E of x equal to 4. And what we were asked to find probability of getting head in the second trial. Please do remember what I observed. If same experiment is performed repeatedly, means again and again and again until the occurrence of one particular event, then expected number of trials required for occurrence of one particular event for the first time, simply don't apply the formula. Directly if you solve as per the procedure, it consumes time. Because the same model question we were already given GATE Electrical 2020 for probability, its expected value 1 by P. You are given E of x equal to 4. But E of x value 1 by P equal to 4, so that P equal to 1 by 4. What we were asked to find? We were asked to find the probability of getting head in the second trial. Head in the second trial means first trial head doesn't occur. So probability of head in the second trial means first trial head doesn't occur. That is 1 minus 1 by 4, 3 by 4. And the head occurs in the second trial. Head occurs in the second trial is 1 by 4. So simply answer it should be 3 by 16. That's it. So have a look at this. This question, after several years, we were given a question from probability and statistics regarding that correlation and regression analysis. Here the problem is 3 points in the xy plane we were just asked to find the slope of the straight line that was found using least squares method. So simply you can do like this. Here what are the values? X value minus 1, Y value 0.8, X value 0, Y value 2.2, X value 1, Y value 2.8. Observe summation of X. Summation of X is 0, summation of Y 3, 5.8 and summation of XY. What is summation of XY? That is minus 0.8 plus 2.8. Minus 0.8 plus 2.8, that would be 2. So what is the formula to find the normal equations? The formula regarding to find normal equations is summation of y equal to NA plus B into summation of X. just now you have seen summation of x is 0. And moreover, we were asked to find slope of the straight line. And do you people know the regression line regarding least squares method is y equal to a plus bx. So this is in the form of just like y equal to mx plus c. So m is the slope, means b is the slope. And you observe here a value, you observe this summation of x is 0. Summation of x is 0, you can't get b value from this. So that's why no need to use this first normal equation to find the slope. We simply go to the next second equation, that is summation of xy equal to a into summation of x plus b into summation of x square. What is summation of xy? 2. Summation of xy is 2. So a into summation of x is already 0. B into summation of x square. Observe that summation of x square is minus 1 whole square plus 0 square plus 1 whole square. Simply 2. So b into summation of x square is 2. So 2b equal to 2, therefore b equal to 1. So what is the slope of the line? Y equal to mx plus c, m is b, so slope of the line is 2. Sorry, slope of the line is 1. Just observe, we were given the maxima minima problem. Sorry, the maxima, the magnitude of the maximum rate of change, it is vector calculus. Do you know the maximum value? Actually, maximum rate of change occurs in the direction of normal vector, and the maximum value of rate of change is simply magnitude of del phi or magnitude of del f. Simply you need to find del f value. This is the way we assume the given function f equal to x1 square. I will directly find del f. How to find del f? I bar into given function derivative with respect to x partially. X means x1. I into given function derivative with respect to x partially. X means x1 plus 3 plus x2 plus j bar into given function derivative with respect to y partially. Y means x2. So therefore plus j bar into here 4x2 plus 3 plus x1. Simply, but plus k bar into given function derivative with respect to z partially. Z means x3, we don't have z variable. Therefore, that is the resulting equation, but we were asked to find del f at which point? 1, 1. So we just have to calculate del f value at the point 1, 1. So if I take x1 value 1, here x1 value 1, x2 value 1, 2 plus 3, 5, 5 plus 1, 6. Therefore it is 6i bar, 4 plus 3, 7, 7 plus 1, 8. 8j bar. Find magnitude of del f. Magnitude of del f is square root of 6 square plus 8 square, that is 10. Square root of 100, that is 10. So therefore, the maximum rate of change, the maximum value of rate of change of the given function is modulus of del f, that is simply 10. And observe this, some data is missing, but according to the information that I have received from the students regarding the question we were given on line integral from vector calculus, and actually from last 25 to 30 years, the first problem regarding line integral was given in polar coordinates, and that is actually we were given the curve is r equal to 1 plus cos theta, which is called chordioid, what we have studied in the semester course, and r equal to 1 plus cos theta chordioid, it would be r equal to 1 plus, actually some other data was also given, r equal to 1 plus cos theta chordioid. This is, I think this data is missing, and again this is r equal to 1 plus cos theta chordioid, and we were asked to find the value of the integral. R equal to 1 plus cos theta curve, we were asked to find the value of the line integral. Line integral is integration of f bar dot dr bar, that is equal to f bar dot dr bar, means minus y into dx plus x into dy. Do do you people know we were asked to find the value of the integral around the chordioid r equal to 1 plus cos theta, which is a closed curve. Therefore, the line integral around a closed curve can be solved using Green's theorem or can also be solved using Stokes' theorem as well. So, but I want to solve this problem using Green's theorem, therefore, which is in the form of integral m dx plus n dy, that is equal to double integral dou n by dou x, which we also call it as del n by del x, that is 1 minus dou m by dou y, that is plus 1 dx and dy. So 1 plus 1 is 2, and moreover double integral dx and dy is area of given chordioid. If you people know area of given chordioid, you can directly write the answer, problem completed. But most of us, we have already forgot the area of chordioid, that's why we have to solve, that's why I am teaching as per the procedure. So area in polar coordinates is r, dr and d theta, and moreover, so this is the chordioid. If you wish to take the limits now regarding this chordioid, we have to take a radial strip like this. So therefore the strip, it is entering, r limits is 0 to, it is, the strip is coming out through this curve. Therefore r limits is 0 to 1 plus cos theta. R limits is 0 to 1 plus cos theta, and the theta limits, you observe that theta limits here 0, pi by 2, pi, and again 3 pi by 2, 2 pi. So covering all quadrants, therefore theta limits is 0 to 2 pi. Now we need to integrate with respect to r first, followed by with respect to theta. Therefore, integration of r dr. Integration of r dr is r square by 2, 2 cancel. Therefore, theta limits is 0 to 2 r square. If I substitute r value, then it is 1 plus cos theta whole square into d theta. Now we can simplify that, you will get the answer. Otherwise, I will write one more step. This is equal to integral 0 to 2 pi 1 plus cos theta whole square, that is 1 plus cos square theta plus 2 cos theta. You are able to simplify this. I think you may get the answer 3 pi 0 to 2 pi 1 plus, this is 1 plus cos 2 theta by 2 plus 2 cos theta d theta. This is equal to integral 0 to 2 pi, this is 3 plus 4 cos theta plus cos 2 theta d theta, integral 3 d theta. Now you observe one thing simply, integration of 3 into d theta. Integration of 3 into d theta is 3 theta between the limits of 0 to 2 pi r square by 2, and verify integration of cos theta. Integration of cos theta is 6 sin theta. Sin theta, if I apply the limits now, sin 2 pi minus sin 0, it is 0. Again integral cos 2 theta is sin 2 theta by 2. Again if I apply the upper and lower limits now, sin 4 pi minus sin 0, that is 0. So therefore any calculation mistake is there, you just cross check, and therefore by applying the limits now, we just got 6 pi, and the remaining part of the integral is 0. And moreover, you observe integral r square by 2, that 2, these 2 cancel, therefore 1 plus cos 2 theta, here LCM is 2 is there. So therefore answer 3 pi. If you can calculate like this, you may get the answer, right? So next, the remaining part of the half of the session regarding engineering mathematics, my colleague Manikumar sir will take over the session, and that will be the last. Thank you.
Okay, welcome back students. I am Dr. Manikumar here to discuss the remaining part of memory based questions on mathematics. Already sir discussed 4 questions, Venkatrao sir discussed 4 questions, 3 more questions available with us. Now we are going to discuss those 3 also. You see, which of the following option represent the given graph? One graph was given like this, 4 options given. This graph represent, which function represents this graph? Very clear, you see, this graph is symmetric about the origin. Very clear, this graph is symmetric about the origin. Yes, a graph is symmetric about the origin means, you know, for every odd function is symmetric about the origin. You see the options in 4 options. What is odd function definition, you know? You know, in odd function definition, just a minute. You see, what is odd function definition? If f of minus x is equal to f of x, that function is odd function. Very clear. Here in option A, if you take f of x is equal to x to power minus mod x. So what is f of minus x here? That is minus x to power minus mod x will come, that is minus f of x. You see, among the 4 options, only option A is the odd function. Remaining 3 are not odd functions, very clear. So the graph is so here option A is an odd function, graph is looking like it is symmetric about the origin means option A is correct. Okay, right. Now coming to the next question. In the, see, one diagram given like this, the given figure, the vector u and v are related as au is equal to v. Here the vector u given like this and v given like this. By transformation of the matrix A, so A into u is equal to v. What is A here? Actually, completely it was not there here. What is the matrix capital A? So directly already options are available. Verify from the options, you can save your time. Already A into u is equal to here, A into u is equal to v given. So A matrix we don't know. U, already u is 4, 3 is equal to 5, 0. Is it? Now verify the options one by one. See, here option B coincides means A into u should be equal to v. So if I take from option B 4 by 5, this is 3 by 5, next minus 3 by 5, 4 by 5. If I take like this and multiply, then what will get here? This is 16 by 5 plus 9 by 5. 16 by 5 plus 9 by 5 is 25 by 5 will get 5, and minus 12 by 5 here plus 12 by 5 will get 0. Very clear. Among the 4 options, option B coincides. So option B is correct. Okay. Don't waste your time. You from the options you can verify like this. So option B is right for this. Now coming to the next question. Say this. For a given vector W is equal to 1 to 3 whole transpose, the vector normal to the plane W transpose into X. W is equal to 1 to 3 whole transpose, the vector normal to the plane W transpose is equal to 1. Very clear here also. W transpose into X is equal to 1. That implies, what is W transpose into X? That is 1, 2, 3. W transpose is given as, that is 1, 2, 3. Sorry, 1 minute. One, 2, 3 into x you can take it as x, y, z is equal to 1. That is nothing but what it is, x plus 2y plus 3z is equal to 1. Is it? Now, x plus 2y plus 3z is equal to 1 means let it be. Now, the vector normal to this plane, let it be phi. Let phi is equal to, you can take it as phi. Phi is equal to x plus 2y plus 3z minus 1 is equal to 0. Now, vector normal to this plane means what it is? Gradient. Vector normal to the plane means normal to the plane is nothing but the gradient. What is gradient of phi? Dou phi by dou x I bar plus dou phi by dou y j bar plus dou phi by dou z k bar. What it is? 1 I bar plus 2j bar plus 3k bar. 1, 2, 3. What means this is a vector you can represent like this 1, 2, 3. Which option is right? Option 1, 2, 3. Actually in options a transpose given, but that is not correct. Here also matrix is nothing but W transpose here, a small typo error. W transpose is given like this. Actual matrix is like this. W transpose is nothing but this one. So final answer is nothing but I bar plus 2j bar plus 3k bar means that is a row vector 1, 2, 3. So which option? Option B is correct. Okay. These are the questions on mathematics.
All the best. dear students, I hope you did well, and with all our best blessings, you will get a very good result, and we are there to always guide you. So after this discussion, you can estimate your marks, but still we will have a detailed discussion and accurate paper solutions once the official paper come out. So as a team from ACE Engineering Academy and ACE Online, we wish you all the best and hope for the best result and for your future endeavors. All the best. Yes, my dear students, I hope you did well, and with all our best blessings, you will get a very good result, and we are there to always guide you. So after this discussion, you can estimate your marks, but still we will have a detailed discussion and accurate paper solutions once the official paper come out. So as a team from ACE Engineering Academy and ACE Online, we wish you all the best and hope for the best result and for your future endeavors. All the best. You did well, and with all our best blessings, you will get a very good result, and we are there to always guide you. So after this discussion, you can estimate your marks, but still we will have a detailed discussion and accurate paper solutions once the official paper come out. So as a team from ACE Engineering Academy and ACE Online, we wish you all the best and hope for the best result and for your future endeavors. All the best.